Hello, hi everyone.
Good morning, good afternoon, and good evening, everyone, depending on where you're joining us from today. So, I hope you had an amazing vacation and you're ready to get started with the very new AI 42 conference called Real Life Machine Learning. And we are very happy to have our amazing hosts together with us, Gosha and Håkan. Welcome to all of you. How was your vacation?
Good. I still feel like I'm not back from holiday. Still on holiday mode.
How about you, Håkan? Did you have a nice vacation?
Yes, I had a nice vacation. So I've been working for a month. So I think I've acclimatized.
Oh, okay. That sounds interesting. Let's talk a little bit after this session today. All right. So today we are going to bring you three amazing speakers again who are going to bring their own solutions on different real life situations and scenarios. And in the end of their sessions, you will have a chance to join our discussion panel where they will answer your questions and we can discuss all kinds of things about their stories. And I think before we get started, since the vacation was quite long, let's refresh our memories with giving a little introduction of who and what is AI 42.
Yes, Steve. Yeah, so basically the background and the motivation here for starting AI42 comes from the recognition that we believe that there's really no good starting material for learning AI. So that's why we started AI42. So we are a strong team here consisting of 3 Microsoft AI MPs. And what we want to do is we want to provide you with a valuable series of lectures that will help you to jumpstart your career in data science and AI. So what we want to do is we want to provide you with the necessary know-how so that we will help you to land your dream job, as long as it's related to data science or machine learning. And the concept is quite simple. So it involves professionals from all around the globe that will explain to you the underlying mathematics, statistics, probability calculations, data science, and also machine learning techniques. And don't worry, this might sound like a lot, but we will guide you through it all. All you have to do is just to follow our channel and enjoy the content every second week. So it will be filled with real life cases and also expert experience. And we have all started from scratch, and we are very happy to help you build it up from there. And you can always stop and rewind the videos or ask for clarification in the comment section. And we hope to assist you on this wonderful journey and have you as a speaker one day. And we think that by creating cross collaborations with other organizations, we will be able to give you the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we would support less fortunate people and organizations that are not recognized yet, even though they deserve it.
So our organization is sponsored by Microsoft and Miles, and we are humbled by all support we get from our contributors as well. And thank you for Levet Pongor for all the beautiful graphics, content, and Maya Marie for the cool intro music before our events. We are in close collaboration with C Sharp Corner and Global AI Community, so our lectures are going to be available also on their YouTube channel additionally to our own data. Nicolette taught, create, and review all our text content we use on our website, our advertisement, and during our sessions. And you can follow us on Facebook, Instagram, and Twitter and become a part of growing community where we share knowledge and fun. You'll find every information that will bring you to an advanced level in the field of artificial intelligence and data science. You can also watch our recorded session on YouTube channel and find our upcoming session on our meetup page.
And we also have a code of conduct here. So the code of conduct outlines the expectations for participation in our community, as well as the steps for reporting unacceptable behavior. And we are committed to providing a welcoming and inspiring community for everyone. So be friendly, be patient, be welcoming, and also be respectful with each other. And you can see our full code of conduct on this link. We would also like to announce here that we are very happy and very grateful for being nominated for a Nordic Women in Tech Award in the category of Initiative of the Year. So we'd like to thank all of you who has supported us and watched our show, and also for this nomination to the Nordic Women in Tech. And if you want to speak here at our session, we have an open call for speakers. So you can just go to Sessionize on this address that you see here and submit your proposal, and we will get in touch with you shortly. With that said, we can go back here to our guests and our speakers.
Yes. So our first speaker is Becky. Oops. Hello, Becky. Sorry for that. Hello,
Hi,
how are
Becky.
you today?
Doing well. It's bright and early here where I am, so I'm excited to start my day talking to you all.
Yes, you're joining us from St. Louis.
Yep, right in the middle of the United States.
Yeah, that's perfect. So you are a practice lead of data and analytics for Sentry Consulting. Can you tell a little bit what you are doing? What is your job?
Sure. So I lead a group of people that does a lot of problem solving using data from engineering and visualization to some more data science, machine learning type things, as well as architecture. I lead our practice that's located here in St. Louis, but we're fully remote, so we serve a lot of clients all over the place. So I'm really passionate about empowering other people to be able to solve problems. My background's in engineering, and I get to do that every day. So I'm really excited with my job.
Yeah, and this session today, it will be really amazing because you're talking about Disney and you are a Disney nerd as well.
I am. If I had turned my computer the other way, you could see my desk is all Disneyed out. So in my ample free time, I do Disney analytics. And so we're going to talk about some of the data science behind that today.
Yeah, I'm looking forward for that. And it's really inspiring to go there and just find the real things in cost less and no timing to lose.
Right.
Especially when you have children and they are very busy with all the attractions.
Oh, yes. Yeah. Disney's not just for kids, though. Adults can have fun too.
Of course. Of course. So, should we start your presentation because we
Let's
just
do
can't
it.
wait to learn more.
Yeah.
Yeah, great. We'll just have a quick transition and then we'll leave the stage to you, Becky.
Thank you. Wow, that might have been one of the more exciting intros I've ever had. So today I'm going to start us off with a little bit of fun. So I get to be the splashy intro as we dig into this machine learning and how we can apply that practically. So we're going to talk about hacking your vacation and using data to do that. But really, I'm going to be using this as a sort of example to provide a framework on how we can apply data science in a way that serves humans, and that repeatable framework for how we're going to approach these problems, no matter what they really are. So let's get started with a quick intro to who I am. We talked a little bit about my job. So I lead a data and analytics practice here in St. Louis. My background, though, is in biomedical engineering. So that's what my degrees are in. And I acted as a biomedical engineer for the Department of Veterans Affairs for almost a decade before I got into really the world of consulting and data. I've dabbled in a lot of pieces and areas of data, from data science to architecture to visualization. But now I really focus in on data strategy and road mapping while still doing a bunch of those other things for fun, which is what we're going to talk about today. So that's me, but this is also me. So I have two young kids, ages 6 and almost 4. She has a birthday here in 10 days. I have been a very lifelong Disney fan. My family went to Disney World specifically about once every 3 years growing up. I'm also a vacation super planner. We don't just go to Disney. We have a goal to bring our girls to every United States national park before they graduate from high school. So I have spreadsheets planning out vacations literally years in the future to try to accomplish that. I also blog about data, specifically Disney data, and I've done over 100 posts in the past year, which is wild. And I have a YouTube channel. So on the YouTube channel, we'll see some information from this channel later in this talk. I've got an over 20 video series with over 150,000 views, and it's all about this sort of intersection of Disney and data science. So for a data science topic to be that popular is a pretty good thing. And we're going to talk about how communicating that the appropriate way helps it be applicable to the masses. So in this sort of realm of my life, and I talked about my ample free time with a consulting job and 2 young kids. So mostly what this means is after my kids are in bed, I specialize in crowd and touring analytics and helping people to make the most of their Disney vacations. So that's a little bit more about me. Now, as I think about my vacations, I usually have some specific goals, and specifically related to these Walt Disney World vacations. And setting out these goals or questions at the beginning of this process is how I approach every data science problem. I'm not just swimming through data and hoping something comes out at me. I have a very specific question to answer or goal in mind at the beginning. And so today we're going to very quickly go through 3 vacation goals for Disney vacations. The first, where we're going to be spending the most time, is avoiding crowds. And then we also want to save money. Disney vacations are ridiculously expensive, so we want to save money where we can. And we want to enjoy our vacation. It doesn't matter much if we go to an empty park and don't spend a lot of money if we don't actually like what we just did. So we got to find the right balance here. And as a data-driven decision maker, I want to use data to do that. So that's what we're going to talk about today. So what's the problem? Why is this difficult? I'm going to talk us through one example of one day in the Magic Kingdom. And if my goal is to avoid crowds and save money and enjoy my vacation, why is that so hard if I'm spending one day at the Magic Kingdom? Well, there are park capacity issues. So the parks haven't gotten back to full capacity after reopening after the pandemic. So I might not be able to get in. That would be a big impact on whether I'm enjoying my vacation. Park attendance also varies. I could be in a mass of hundreds of thousands of people, or I could have a relatively empty park. Park attendance also varies by hour. People don't like getting out of bed early when they're on vacation, and so those hours of the day are pretty nice. But once you get around between lunch and dinner, it's really, really crowded. And if I don't know that, I might make the wrong decisions about how I'm touring the park. Ticket cost is variable. Disney knows what the popular times are, and they will charge you more to go during those times. If I don't know that, I might be surprised and not very happy. Operating hours change. We're in the middle of Halloween party season, which is crazy. It's been going since the middle of August at Disney World. And on days where there are Halloween parties, the Magic Kingdom closes at 6 p.m., when regularly it's open till 11 p.m. during this season. And so if I accidentally have 5 hours cut off of my day because I didn't plan, again, not great. There are between 29 and 39 attractions, depending on how you define those and how many are actually open on any given day. So I have to choose between those. There's between 31 and 33 dining locations. I have a lot of opportunities to make good or bad decisions about what I'm feeding myself. There are 9 to 13 different shopping locations, so I can spend a whole lot of money really quickly, especially if I have young kids. I have various different dining preferences, and those dining locations have different quality, so that's going to impact what I choose. Attractions have various popularities, that impacts crowds. Dining locations, irrespective of quality, have their own popularity. Something could go viral on Instagram, and even if it's not very good, everyone's going to be in line to get it. So I need to know about that. There's upsell opportunities from Disney where they try to help me make decisions that will allow me to spend more money. So I have to know sort of the reality behind those. And there are park reservations. So in addition to park capacity and buying my tickets, I still can't get into the park if I didn't make a reservation, which is a new thing post-pandemic. This is a huge amount of data to sort of filter into my one day. And if I don't know about all of it, there are a lot of things that can catch me off guard. And that's just Magic Kingdom. So at Walt Disney World, there are actually 4 theme parks. So you multiply that by Epcot, Hollywood Studios, and Animal Kingdom. And that's not all. There's also 2 water parks. One hasn't reopened since the pandemic, but I expect it eventually will. There's 1 shopping district where people can choose to spend their time or eat their food. And there are 34 resorts on property that are highly themed, and people tend to do resort days there to get their money's worth there as well. And so how does that impact what I choose to do and what everyone else is choosing to do? This is a wild amount of inputs just for one little simple family vacation. So I'm going to ask people to participate now in the comments, because the next step in our process of approaching a data science problem is to go from our goals to what data we need to collect. So I just presented sort of this overarching problem statement, all of these different inputs that I need to know about. If you were thinking about what might impact crowds at Disney World, what would make a day in the parks more crowded or less crowded, what data sets or numbers or data sources would you try to get access to at a very high level to try to start answering this question with data? What do you think those predictors might be? I can see the comments, and I'm also good with virtual uncomfortable silence. It's one of my superpowers. So I'm going to wait a minute and see if anyone wants to be brave and have any comments about potential data sets. Otherwise, I've given it away that I'm going to click through on this slide and you'll get some data. But it's more fun if you interact. I'll give it 15 more seconds. All right, we'll just keep powering through. You're going to make me give away all the answers, which is fine. So here's some of the data I would collect and that we do collect. On the left-hand side are some pretty publicly available things. School calendars. So one of the biggest determining factors of Disney crowds is whether school's out, because you're going to bring your kids when school's out. A lot of people will anyway. We also have economic data and travel spending. A lot of people stopped taking Disney vacations during the pandemic with the economic uncertainty. Also pandemic waves. So this has less of an impact now that we've sort of entered this steady state post-pandemic. But as we were in the early waves of like Delta and Omicron, you would see the wave peaking. And as it was starting to peak, people would cancel their vacations 2 or 3 months out. And so it was a little bit of this indicator that 2 or 3 months from now, the parks are going to be empty, even though the wave is peaking right now. Travel agent trends, you can get that data pretty easily. A lot of people use travel agents to book Disney trips. Prior years of actual results, you can see how crowded the parks were every day. Weather, people don't like being in a rainy theme park, and spoiler alert, Florida is very rainy a lot of the time. Operational info, rides can go down and impact the whole capacity of the park, make wait times go up elsewhere. And then on the right side, we see some maybe not as publicly available information. You can scrape posted wait times. So this is a little bit of a trick. Disney has an app that you can use while you're in the park, or even when you're not in the park, to see what the wait times are, and they update real time-ish. So you can scrape those and then have a running history of what those posted wait times look like. We also have a mobile app, and users can submit their own wait times. So we can know not only what's posted, but what people actually waited at those attractions during different times of the day, because those posted and actual wait times can be significantly different. We have an in-park testing team that goes and waits for rides to help get us data where we don't have it. We have post-visit user surveys that give us some satisfaction data about things people experienced. We can scrape cost info, ticket prices, etc. And we can scrape dining reservations. So if all the dining reservations are gone for a day, either they're having trouble staffing the restaurant, or we're going to have a lot of people in the park and they're planning ahead what they're going to eat. So all of these things can give us a lot of information about what those crowds are going to look like and how satisfying certain parts of our vacation might be. So now let's talk about avoiding crowds. This picture I like to share because this is when parks were still at something like 50% capacity post reopening, and it's when masks were still required outdoors. There's a couple people without them in this picture, and this is before the park even opened. So park capacity at 50%, half as busy as it could be, and before the park even opens, which means it's early in the day and a lot of people are still asleep, and this is still what the crowds look like. So we definitely want to avoid the crowds because it can get a lot worse than this. So I'm going to take all of that data, and I'm sort of skating over a lot of the technical part of the machine learning here. And that's on purpose because we're going to get technical later in the day. But I wanted to keep my talk lighter and talk about the process and the people focus. But we take a lot of those data sets and we use a really simple tool stack, including AWS and Python and TreeNet, and we run those models to figure out what the crowds are going to be like. And I'm presenting this in a way that's sort of opposite of how we actually do the data. So what comes out of that data is essentially a minute by minute prediction for what the wait time is going to look like each day for each attraction over the next year. And then we take all of that attraction specific data, aggregate it to a park level, and assign each park a crowd level. And so these numbers go from 1 to 10. But today is September 7th. So if I look out over the next week, I see crowds aren't really that high, which is nice. And I can see how they differ from park to park as well. So it looks like September 13th would be a really great day to go to Magic Kingdom because it's a crowd level 1, which is the lowest it can get. I have a lot of information here. I have information about park reservations being available. All of these letters being green means there's still reservations available, which doesn't happen very frequently. It tells us the parks aren't going to be very crowded. I get information about park hours, parties, festivals, all of these things that impact which park I might want to choose to go to. So this is the highest level view that we have of these crowds. And what does that really mean? I'm going to use Magic Kingdom as my example again. And here we have a table of some of the most popular attractions in the Magic Kingdom, as well as what the posted wait time we would expect the average peak posted wait time to be on each of this various crowd level days. So peak hours at Magic Kingdom are 11 a.m. to 5 p.m. That's when wait times are going to be the highest. And so we sort of take all of this information in about those average wait times and we force them onto a bell curve. So our level 1 days are going to have the very, very, very lowest waits of any day in the year. And those level 10 days are the wild and crazy. You don't want to be in the parks. Level 10 days are happening a lot around Thanksgiving, Christmas, and spring breaks. Bonus, this looks like a roller coaster. So Ray, we've got our Disney theming. But most of the days are going to fall in those level 5, 4, 5, 6, 7 range. That's pretty average crowds. How does that impact what our wait times look like? So this week surrounding Labor Day is always, 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 pandemic or not, always the least crowded time of the year at Walt Disney World. And that's because here in the United States, schools typically start sometime either a couple of weeks before Labor Day or right after Labor Day, and people don't want to take their kids out of school right as it's starting. They don't get to make friends, etc., etc. So we'll always see these lowest crowd days right around Labor Day in the United States. What does that look like? So if I went to the parks on Friday, September, excuse me, Friday, September 2nd, and experienced a crowd level 1 day, we would see that Seven Dwarfs Mine Train would have something like a 60-minute posted wait in the middle of the day. Hey, that's exciting. And then we get other information about other rides as well. So this still looks like a lot. Posted wait times are often higher than actual wait times though, because Disney wants you to feel good that you waited less than what it said at the ride entrance. This is very manageable. If instead we fast forward to the week of Thanksgiving here in the United States, a lot of people are out of school, and so a lot of people are going to Walt Disney World. So we see a lot more crowd levels up in the 7, 8, 9, 10. 8, 9, and 10 is what I would classify as high crowds. So if instead of going on September 2nd, I decide to go to Magic Kingdom on November 22nd, which is something I would never ever personally do, instead of that nice 60-minute posted wait for Seven Dwarfs Mine Train, instead I could have up to 180-minute posted wait in the middle of the day at Seven Dwarfs Mine Train. So I'm waiting 3 hours for one ride. And that's not a great look. And then we can go down even to something like Under the Sea, which is a little clamshell ride. And you just see the Little Mermaid figures. It lasts about 4 minutes. That's going to have an hour-long wait. Peter Pan's Flight, which is right in the middle of the screen here, is about a 1-minute duration ride. You get on a little flying pirate ship and fly through London and Neverland. 1-minute ride, and it's going to have something like a 2-hour wait on these really crowded days. So if I see this, I say, nope, no thank you, not going to go to Disney World on these ridiculously crowded days. But what the crowd calendar can let you do is sort of figure out if I have to go to Disney during Thanksgiving. You don't ever have to go to Disney. If I want to, and the only time of year my family can go is Thanksgiving, I can at least play the numbers a little bit and choose to go to Magic Kingdom on the Friday where it's at crowd level 8 instead of 9. That buys me a little more time. I'm hitting Hollywood Studios on a crowd level 7 day, so that's going to be even better. And I still have to do a 9 at Animal Kingdom and Epcot, but I'm able to sort of arrange things so I'm getting the least amount of crowds possible even on this high crowd level day. We can dig a little bit deeper, and I said this is actually how we start our analysis, but it makes more sense to walk through it from the top down. We can look at crowd level 10 and crowd level 1 days and see how the wait time shapes differ throughout the day, and we can also see how they differ from attraction to attraction. So here I've got these predicted wait times, and some of them are actually in the past, but I needed a good example. For Seven Dwarfs Mine Train, which is it's the headliner of Magic Kingdom, and so it often has the highest waits in the park, versus Dumbo, which is a classic ride that a lot of people feel like they should do, doesn't really have high demand, has a lot of capacity, so wait times are often much lower. If we look on a crowd level 10 day, we can see Seven Dwarfs Mine Train immediately gets really high waits, and so it almost immediately goes up to a 60-minute posted wait. It has a fun little dip at like 10:30, and this often happens at Seven Dwarfs Mine Train. So if we're optimizing our day, we might take advantage of that little dip if we can't get there first thing in the day. And then it keeps increasing. So we're quickly over 100 minutes by the middle of the afternoon. And then eventually, as families start filtering out of the park, getting tired of the crowds, it starts going back down if we can last late into the evening. Dumbo, on the other hand, doesn't increase immediately because people are going to the headliners first. So it keeps a really low wait time until later in the day. And then finally, when people have started doing the headliners or they get tired of those high wait times, they go to Dumbo instead, and its wait time goes up as well. And then it actually doesn't decrease until later in the evening. So I could see how I could start taking advantage of some of this. Crowd level 1, on the other hand, wait time shapes are very different. Often, people will understand in their head that Seven Dwarfs Mine Train is popular, and they want to ride it first because they think everyone else will want to ride it too. So they rush there first thing, even on these days where there aren't many people in the park. And so what that early rush does on these uncrowded days is it makes the attraction very not crowded the rest of the day because everyone that's in the park has already ridden the ride. And so we see this pretty park wide, which is interesting. So there we can see on a crowd level 1 day, we're actually better waiting. Let all those people get it out of their system and go ride Seven Dwarfs Mine Train first. We'll ride it later. It doesn't really matter. And Dumbo has something similar. Everyone's like, oh my gosh, Dumbo has a low weight. Let's go. And it's a little later than Seven Doors Mine Train. And then it drops back down. So all of this is really interesting, and it impacts how we're going to plan our day. We have to make it work for real humans, though. And so this is sort of the next step. I have all of this huge amounts of data, but giving people graphs and telling them go, good luck, isn't really going to work. I technically already have all of the answers, but I'm not making it usable by real people. So that's our next goal. I'm going to try here to pull over and do this real time. So we'll see if AWS is playing nicely today. How would this work in real life? How do I make this data science applicable to real humans? I'm going to create a plan. And this is going to use all of that data and make it usable by me. So I'm going to call this the real life machine learning example. And we're going to optimize it for tomorrow. Let's say you're very inspired and you're going to fly all the way to Walt Disney World tomorrow. We're going to go to the Magic Kingdom. If I'm staying at a Disney resort, I get to go into the park 30 minutes early. And actually tomorrow's a special day. It's Disney Plus Day. And so if you're a Disney Plus subscriber, you get in an hour early. That's a big perk. But I'm going to say I don't get any of those things. So I'm going to start at 9 a.m. and I'm going to plan on touring all the way to 11 p.m. Then I'm going to tell it, me as a human, what attractions I want to ride. And I have some helpful information here. I get popularity ratings. So if I know nothing about Disney World, I can at least pick the popular ones and assume I'm going to have a pretty good day. I will want to ride Splash Mountain at least once. It's still hot and humid in Florida in early September, so I need to cool off. It's a Halloweenish type season, so Haunted Mansion would be good. Big Thunder. Buzz Lightyear is sort of a laser shooting game. My family loves competing on it, so I'm going to do that one twice. We'll do all of these. So I'm just going to add a bunch and tell it that I want to do all of these things during my day. And I'm actually going to see Mickey twice because I love him so much, and ride Pirates of the Caribbean twice. Then I can tell it when I want to take a break. So I can tell it I'm going to Cinderella's Royal Table at noon. This would actually cost my family about $300, so I'm not doing that, but we can pretend. And I'm going to be there for an hour. I'll pretend I have a reservation. Then for dinner, we're going to go to Columbia Harbor House. We'll go there probably around 6 p.m. and be there for 45 minutes. I can also schedule in an afternoon break if I want. Then we're going to see if it plays nice real time. And I have backups on my slides if it doesn't. So it just, in the order I chose them, it just populates them onto this plan. So I can make sure that everything's there that I want to do. And I have some options now. I can tell it how fast I walk, because that's going to factor into how my day goes. I can also tell it to minimize waiting or minimize walking. You can do something like up to 8 miles of walking on average a day at Disney World. So if that's not your jam and you're okay sacrificing a little bit of wait time to not have to crisscross the park a lot, you can do that. I often have to go to Disney with a stroller, so I'm going to say minimize the walking. It'll still minimize the wait too, but it won't make you crisscross the park to do it. Then I scroll down and I have some options. I can have it evaluate this plan in the order that it currently is. That wouldn't be smart right now. But if I organized it myself and I just wanted to know what my wait times were likely to be, I could click evaluate. Instead, I'm going to let it optimize. And usually this takes about a minute. So we're going to see. This is always the fun part of the presentation. We see how nice it's feeling. But I think it should take something like a minute or less. It's waiting for the results. And when it returns, it should return that optimized plan. So it's going to take my input as a human that wants to visit Disney World, just the attractions that I want to do. And it's going to take advantage of all those little dips, of all the various wait time curves for all of these attractions that I've chosen, something me as a human could not do on my own. And it's going to tell me what order I should do things in. And I can see here it starts me in Tomorrowland. It's getting my 2 rides on Buzz Lightyear out of the way immediately. Then I'm going to Space Mountain, which is also in Tomorrowland. So yay, I don't have to walk. Then I go to Fantasyland. Then I get a little bit of a break until dinner, which is a little awkward, but I didn't choose enough activities for my day. And then I end the day in Frontierland and Adventureland, and I see Mickey on my way out in the evening. So it's that machine learning engine in the background is figuring out all of those wait time curves and optimizing how much time I'm waiting. So I'm getting 244 minutes throughout the day waiting. For 17 steps, that's really not that bad. I'm spending 46 minutes walking, so it's trying to minimize that as well, since I told it to prioritize that. So yay, it worked. We got a real life example, and that's pretty exciting. Okay, so I can blow through these. But even having that and making my plan in advance for tomorrow doesn't help me much if I'm in the park and I just have a printed out piece of paper. What if I'm told to go to Space Mountain third, but Space Mountain's down? Now my whole plan is out the window. But we can have that real-time information. I talked about scraping those actual posted wait times from Disney. So then I can know real time if, for example, Splash Mountain is offline and it's not estimated to reopen until 10:15. And then I can optimize while I'm in the park and get that plan optimized based on real-time information that's coming in. And it'll just take about a minute every time. So then I'm not working on day-old data. I'm working on 5-minute-old data at worst. I can also make some interesting real-time calls. So I can see the posted wait. This is an example for Swiss Family Treehouse, which is a bad example because it's just a walkthrough. But if its posted wait is 5 minutes, I actually get information about its expected wait at the same time. So we know the actual and posted wait times differ. And now I can get an idea of, it says 5, but it's really only going to be 2. So I'll go ahead and write that. Plus, we get data back in. So I talked about timing those actual weights so that we get that information back and can use that to make better predictions. So if I'm in my plan, I'm sent to Space Mountain. Now I can go ahead and click that timer button. When I get in line, I can end the timer when I get on the ride. And now I'm giving data back to these lovely people who gave me this plan so that they can make even more accurate plans in the future. So having that on the phone in the parks is pretty much the biggest deal. So it's really that human-facing element of the machine learning and giving them that data right when they're making the decision so that they can make the right decision. All right, we spent a lot of time on avoiding crowds, and that's because it's really the most machine learning part of this process. So I'm going to quickly fly through saving money and enjoying your vacation so we can talk about how we can meet those goals as well. So you can see here, I quickly ran what it would cost my family of 2 adults and 2 children to go to Disney that week of Thanksgiving. And we're only getting 4-day tickets. So even just that for my family of 4 would be almost $3,000. So that's not our hotel. It's not our food. That's not all of the huge amount of souvenirs I have to buy my children. None of that. Just getting into the parks is going to cost me almost $3,000. That's a lot of money. So I need to know how I'm going to save money. Really, the easiest way to save money, 1, travel during non-popular times because those ticket costs are going to be much lower. Resort costs will be much lower. But also you want to avoid upcharges. Disney is great at convincing you to spend even more money than you already have. There are things, they range from Disney Genie, which we'll talk about, which is $15 per person per day for getting the honor of booking reservations to skip certain lines, all the way up to VIP tours, which during peak travel season, like Thanksgiving, Christmas, costs $875 an hour with a 7-hour minimum, but you get to skip all the lines along with a bunch of other perks. And you still have to buy park tickets on top of that price. So how do you make the most of your vacation with not spending this extra money on top of all the money that you're already giving Disney? We're going to talk about Genie as a good example of this. And so this is the service where you pay that $15 per person per day. And by paying that, you get the opportunity to use their app to book reservation times where you can use a lightning lane, which is a fast line, instead of the regular standby lane. But the software is not great. The supply of those reservations isn't great. There's a lot of things you have to know to make the most of that. So we can see here, and there's a bunch of analytics behind this, but we can look at those low, medium, and high crowd days based on that scale of 1 to 10. And we can see on average how much time people are saving by using Genie Plus at that park on that day. And so this takes a lot of data into consideration. It takes data about how much time you save at each attraction compared to standby, because we need to know those weight differentials, and how many reservations you really can make in a day. Because if you make one, you then have to wait 2 hours to make another one, or you have to use your first one. There's a bunch of rules. So we can add all of that together with a bunch of algorithms and figure out how much time you should expect to save using Genie. Then we can plot it on these various crowd levels at each park. So we can easily see here, I'm never buying Genie Plus at Epcot on a low crowd day, because it's only going to save me about 44 minutes throughout the course of an entire day. For me, $15 per person, family of 4, I'm not spending $60 to save 44 minutes. On the other hand, if I went to Magic Kingdom on a medium crowd day, I could save up to 216 minutes compared to standby by buying Genie Plus. So $60 for saving over 3 hours, 3.5 hours. That's a lot of time. It frees me up to do other things in the park. That might be something I'm more willing to do. So enabling these better decisions about our vacation. This is some of the data that goes into that calculation. And so these are average time savings for each of the attractions that offer Genie Plus, and these are the top 11 or something. I can see if I use Genie Plus at Slinky Dog Dash that I can save almost an hour with just that one reservation. Slinky Dog often has high wait times, but also because of these time savings, its reservations on Genie Plus frequently sell out by 7 a.m. the day of your visit to Hollywood Studios. So you have to work really hard to get that reservation and wake up early. So similarly, we see these time savings, and these are the attractions that are worth using Genie Plus for. You can see other attractions that aren't on this list, things like Mad Tea Party, which is spinning teacups at the Magic Kingdom, has an average of a 2-minute wait savings. So why would you use one of your reservations on that? You shouldn't. But you wouldn't know that unless you have the data. We can also see, so this is a heat chart of when those reservations sell out. So this example is Animal Kingdom on low, medium, and high crowd level days. The colors represent your ability to make a reservation for that attraction. So I can see on high crowd level days, Kilimanjaro Safaris is almost always sold out by 1 p.m. So I can't expect to make a reservation for it after that point. If I get up at 8 a.m. and I make my first reservation for it, my return time is probably going to be 11:15 a.m. That's when I get to use that shorter line. So this helps me figure out when I should make reservations for what. Finally, we're going to talk about enjoying vacation. And here's my two littles enjoying their vacation. I think this was our September 2020 trip, which was actually a really good one. And this really isn't machine learning at all. I'm just throwing it in here for the sake of showing how simple analytics can also be helpful in a situation like this. In our post-visit surveys, we collect information about dining satisfaction. You just give every restaurant you went to a thumbs up or a thumbs down. Really easy. We can convert that into a % satisfaction. We have really high sample sizes, so these are pretty accurate. We also scrape all that menu cost data, and so I can get the average entree cost of each restaurant as well. I can plot those two things together and get this sort of, I call it a magical quadrant, like Gartner's Magic Quadrants, except it's Disney, so it's magical. And I can figure out the restaurants in the top right are high satisfaction, but also high cost. For me and my family, we're going to try to go to the top left quadrant, things that are high satisfaction and also below average cost. What do we want to avoid? The bottom right quadrant, things that are above average cost and below average satisfaction. I can hover on these and figure out which restaurants those are. And I'm not going to make reservations there. I'm not going to eat there. And chances are I'll enjoy my vacation more. We can do the same thing with reservation availability. So on our site, we have a reservation finder. And so if you can't find a reservation for a restaurant that you want, we'll ping it something like every 15 minutes and then text you if one becomes available so you can go grab it. So we'll know which restaurants have little or low reservation success. Those are the very popular restaurants. And we can plot that against satisfaction as well. And so that top right quadrant are restaurants that are easy to get into. They have high reservation success and they also have high satisfaction. The ones that we would want to avoid are in the bottom left, really hard to get into, but also really low satisfaction. So why would you put forth the effort? That's just going to be a frustrating experience. We can look at hotels. We can plot average cost. And so this is average cost across all room types, across all nights of the year. So we're averaging a lot of things for each of these resorts, and we can get satisfaction. So we have a Likert scale for satisfaction. We can average that out and plot those. We can do confidence intervals around them to tell us which resorts overall are good value for the money and which are poor value for the money based on satisfaction. So on this table, we can see Saratoga Springs has about average cost. It's right in the middle, but very below average satisfaction. Now this is silly because it's still 4.5 on a scale of 5. So it's still pretty satisfactory, but the value for the money isn't there. Compare that to something like Port Orleans French Quarter, which has much below average cost, pretty low, still over $300 a night on average, but its satisfaction is much higher than what we would expect given its cost. An interesting thing about this graph that I'll point out, the villas at Grand Floridian, you see that average nightly cost of $1,500 for one room, and yet its satisfaction is higher than we would expect given the cost. So a little bit of silliness with this visualization, but it can at least inform a little bit where I might choose to stay because that's a big expense. I can also pick within the resort where I want to stay. I can get a lot of data about this. I could go into a lot of detail, but not all rooms are created equal. For example, this is at Animal Kingdom Lodge, which is my favorite resort. At Animal Kingdom Lodge, you have standard view rooms and savanna view rooms because there are animals roaming in the savanna outside of the resort. Those savanna view rooms are on average about $200 a night more expensive than standard. But if I can use this little map, I can figure out that this circled room here is rated as a standard view, but it very obviously has animals right outside of it. And I can see comments about it. I can see other people rate it. So I can request that room. So right here is a request tool we can send to Disney, and we can ask for this specific room and pay less for it. We can also get information about specific attractions. We have people rate them based on their age. So I can go and plot attraction satisfaction versus weight. And so again, I'm going to be aiming for the top left, which are attractions that have below average weights, but above average satisfaction. And if I know nothing else, I'm probably going to aim for those in my day because I know I'm likely to be satisfied with them. And I also don't have to spend a ton of time waiting for them just in case I don't. So we can make those sorts of decisions as well. Woo, I did it with 1 minute left. It's a little bit shorter than my normal presentation, but I've listed a bunch of ways to contact me here. I know we've got the panel coming up later this evening for you all. So if you have any questions, you can drop them in the comments or just be prepared with them for later today. Otherwise, you're more than welcome to look me up on these sites as well. Always happy to talk Disney data. Thank you.
Hi, Becky. Thank you so much for that amazing session. It was really, really exciting. And I really like that there are so many interesting facts that you were like lining up to us.
Exactly. It's a lot. I'm sure you can go to Disney and not plan and have a great time too. But if you have the data, might as well use it.
I think it's very stressful even to go to Disney.
It is
pretty more stressful to go there and visit.
Right. That's why a lot of people use travel agents. They just set it and forget it and go have an
especially if you're coming from other parts of the world to visit.
Yeah. Thankfully, especially from the UK, they have really good deals for like lengthy 2-week vacations that make the prices much more reasonable than things that you'll see here. But it does. If you want to not pay an arm and a leg, it pays to do your research.
Yes, thank you a lot again, Becky, for that. And we will come back to you in a little time because at the panel discussion, we will ask even more questions. And So thank you again, Becky. Let me introduce our amazing next speaker, which is going to be Madhumita Mantri. And she's a techno-creative data R&D product lead at Star3 AI. Hi, Madhumita. Welcome. How are you?
Hello, everyone. I'm doing well. How are you?
I'm really excited about your session.
Me
And I'm
too.
very happy to see you. But before I can give it over to you, can you tell a little bit about what techno-creative means?
Oh, that's an interesting thing. Well, I spend a lot of time in technology, and I consider myself very creative. So combining the two, I call myself techno-creative, and I'm really passionate about building impactful products for users and making user life better, and yeah, bringing my techno-creative angle to that.
This is really interesting. I would love to hear more about this. For example, I know that you enjoy solving problems for your users and deliver successful outcomes for users and businesses as well by unlocking data potential. But you're also talking here about creativity. Will you talk about this as well in your session?
Yeah, that's a great question. Well, I will definitely cover some of that. And I'm also going to cover some of the interesting work that my current company is doing, which will be extremely valuable to the user. So, yeah, looking forward to it.
And me too. And as you are passionate about data, applied AI, coaching, public speaking, and social goods, and I also seen you were talking at different conferences. But can you remind me which conferences we could see you in this year?
This year, okay. There is an AI developer conference later this year in October. Going to
Okay.
talk about that, and also our company is hosting a huge conference in real time analytics space.
Wow.
And I will highly recommend people who are interested in the space where you want to see real time analytics and how it can make wonders. And yeah, I would highly recommend to attend that conference. Yeah, and to make data driven decisions, of course.
And that is really important topic actually. And today you will be talking about why is it important to unlock actionable insights from anomalous events and how Third Eye empowers users to solve multiple use cases at ease with scale and with accuracy. And so do you think you are ready to get started?
Yes, I am.
Cool.
So,
Then,
Madhumita, could you also please share your screen?
Yes.
and when you are done that, the
Sure.
stage is yours.
Great.
Oh, great. Okay.
Are you
Have
all
fun.
able to see my screen?
Yes, in a short while here, we just have a quick transition.
Hello, everyone. I'm Madhumita Mantri, and I'm super excited to be here to talk about one of my favorite topic, unlocking actionable insights. And we will look at how Startree Third Eye is going to help unlocking those actionable insights. The team at Startree is building this extremely powerful application, which will be very valuable to many of you. And I'm very excited to cover some of that today. So, quick note about me, who I am. I started my journey in software consultancy and building BI and web based applications. I then transitioned to CRM and BI space, worked at Yahoo, NetApp, wearing several different hats. And then my dream company at LinkedIn, I landed and got to work on data overall in data R&D, and I was lucky at that time to work on AI, data science, data analytics and CRM space. I was a user, and then I started feeling the pain that user goes through. And then I was interested in diving into the products and platform that enable these users and then make their life better, data users especially. After that, I transitioned and moved to PayPal to work at an enterprise company, how that would look like as a senior product manager. I was part of their enterprise data platform team, and I launched enterprise data discovery, data quality, and observability. And now I'm working as a product lead at Startree.ai. Startree.ai is a early stage company in the Bay Area. It's fast growing. We recently got our Series B funding and super excited to work here. The team is working on real time analytics and making like user facing analytics successful. And we're trying to improve the decision maker life by enabling faster analytics at blazing speed. And the insights enablers, data producers who are enabling these things for decision makers, we are also extremely empathetic about them, and we are focused on how to make their life easier and productive by providing platforms and tools that will make their life easy. And today I'm going to talk about anomaly detection platform, which I'm extremely passionate about, and Start Read Third Eye is all about that. Well, something not on my LinkedIn profile, I enjoy my time spending with my family and friend, mostly in waterfront, something I really enjoy. And besides that, I'm also into Bollywood dancing and karaoke. Without further ado, I will dive into the agenda, what I'm going to cover today. Well, why do we care for anomalous events? And how can we unlock those insights, actionable insights from those anomalous events? And I'm going to give you a demo walkthrough of Strategy Third Eye to unlock those actionable insights. A quick note, we have recently launched Strategy Third Eye Community Edition and also self-serve analytics free trial. So it's for users like you. If you're interested in unlocking actionable insights and you want to give it a try, then it's definitely out there, and we will talk about that, some of that, when we wrap up this talk. So first thing comes to all of our mind: why do we care for these anomalous events? Well, most of us are always worried about what are the potential areas of risk when we are running a system or running a business or anything that we are doing at a company. So our goal is to reduce those risks. And how can we do that? Well, one, you'd like to monitor those risks, and two, how you can get those actionable insights so that you can make informed decisions when something goes wrong. So let's dive into a real life example walkthrough. As you can see in the slide, a CEO at a company, and this has happened in real. When I was working at LinkedIn a couple of years back, when the CEO of the company will wake up middle of the night by looking at something went wrong and that impacts the business, and he would have sleepless night because of this. And as soon as he notices that, he would inform a group of data scientists, data engineers, and a group of analysts and business operations team. I'm sure many of you might have faced this problem or facing this problem at present at your company. And when that happens, at that time, we didn't have sophisticated tools or platform that could make the life of the CEO better, or the people who are like you, data scientists or engineers, or any one in the business operations or product analytics team would really panic, and then get into a room and then start looking at what went wrong, why went wrong, and how we can resolve that. So when this used to happen at that time, and I'm sure this is not common, but still happens at many company. I've worked at PayPal, Intuit, and I've seen that repeatedly. This kind of patterns where only handful of people know what exactly to look for, and a handful of people might take several hours to figure out what's going on. This majority of people at the company wondering about what went wrong. And if you are an end user of an data product, whether like something like merchant of PayPal product, so you will be wondering what went wrong and why went wrong, and you're constantly reaching out to this handful of people who are super occupied answering all these people, all these stakeholders. So if you are one of them, you have felt the pain, and we saw that at LinkedIn. And the founder of Startree Third Eye and the founding engineers at Startree at that time was working at LinkedIn, and they felt the pain, and they said like, why don't we go ahead and fix this problem? And that was an inspiration when Startree Third Eye was born. Well, before I can start talking about Startree Third Eye, I want to quickly talk about how we can help these users who are feeling the pain of answering this large group of people. How about democratize this whole thing so that the handful of people who were data engineers, data scientists, or business operations team, they can focus on problem solving rather than figuring out or trying to spend cycles in finding out what went wrong, where one went wrong. So for that, definitely unlocking the actionable insights and democratizing this will be very helpful for these group of people. And for that, what we need to do? Well, first thing is, as I was talking about earlier, reducing the risk. For that, we need to monitor those critical KPIs, which is the key performance indicators. And these KPIs are built from several data sources, and as Becky was covering earlier, I'm super impressed with Disney Genie. And I'm sure, like, I mean, an app like Disney Genie, if you're running, and there are definitely critical metrics that you're monitoring. She was showing the analytics part, and users may freak out if some of these key KPI indicator falls down, because it results in the ultimate impact to the end users. And it definitely impacts the user experience. And that's the extreme right corner that you see here, which is the finding the impact to the end users and how it's impacting their experience. And in the middle is what is the magic. Like, if you could, as a user who are owning these products or experiences, or platforms, and you can identify those anomalies before your end users can figure it out, you can share those actionable insights from this by unlocking actionable insights from those anomalies. And overall, like, you can be more proactive than reactive and help the ultimate end users. And the ultimate end users can be users of application, or they could be decision makers as well. So, with that, I would like to introduce Startree Third Eye and how it's helping the space. Well, using Startree Third Eye, you can fast track problem solving and improve decision making using those actionable insights from anomalous events. And in a few, I will show you a demo which will tell you how you can do that. It has a little bit about Startree that I want to quickly mention. It has three pillars. First pillar is connecting to data, and you can bring in real time or batch. It's built on a top of Startree cloud platform, and you might have been familiar with open source Apache Pinot. So it's current. It's like the managed services of that is Startree cloud platform. And Third Eye is built on top of that. So it uses the power of Pinot and then make things in real time. So in real time, you can onboard all your metrics and start monitoring them. It has smart detection alerts and which will help you to identify those anomalies in real time. So, what I meant by smart detection and alerts, this is where if you are a user or a developer who have tried using anomaly detection algorithms before, I'm sure you would have felt the pain, which takes into consideration like one is data preparation, then enabling the insights, then running some data pipelines, and on top of it, you write code to apply anomaly detection algorithms and then identify outliers. And during this whole process, there are several challenges as a user you may face. One is definitely making like such an building such an application is not easy, running on your own is not easy. It turns out to be a lot of operational overhead. And also in addition, when you're tuning an alert, you run into a lot of issues in terms of alert fatigue because sometimes the alerts are noisy. So hearing or understanding these all pain points, strategy has made this experience really easy to use in terms of they have proprietary algorithms which have been built out, and we give a low code no code experience for you to just plug your data and use those proprietary templates or algorithms. Don't have to write a lot of code, and you can all of that you can do all of that very easily and not worry about the operational overhead as well, and just focus on problem solving and monitoring. The third part, strategy third eye does it really well, is the interactive root cause analysis. So once you find something went wrong, you look into different dimensions and data. As an example, if your page view drops, then you are looking at whether the drop is in mobile or whether the drop is in desktop. So those are the insights you're looking, and seeing those insights in real time is not an easy experience, and it's also expensive. And strategy using strategy Pinot, which is what third eye is built on top of that, it makes it super easy in terms of less cost in terms of cost of operations, and also running and real time analytics, so you can uh, do fast like queries on top of the Pinot data source. And then those queries are mostly aggregation in nature, and that will help you to identify the root cause. The aggregated queries you use in detecting the alerts, because ultimately insights and identifying an anomalous events in the insight, if I do talk in simple terms, you are running a bunch of query and running aggregations on top of that. And the main problem everybody finds in that space is the detection time by running those queries in real time is extremely painful and cost intensive, and that's what it addresses very easily. So, what's special about Third Eye? Talked a lot about Pedo, or the Starry Cloud platform on top of which the Third Eye has been built. Besides, it also helps, because of that, in fact, it helps you to have reduced mean time to detect anomalies. And that's probably one of the main things that everybody looks at when you're trying to use an anomaly detection experience and unlocking those actionable insights. It has the low code no code detection techniques pre-configured for you, so you don't have to worry a lot and just focus on problem solving. So that makes it very easy, and the easy to use interface to do interactive root cause analysis and get to the final like unlocking those actionable insights. We have a growing community. You can join us, and we have make it source available. So as a developer, if you are interested in exploring, you can use it. Architecture wise, we have made it super flexible and has a lot of plugins. So in fact, we have kept the developers in mind, and while it can use low code no code experience, you can also go extra mile and then try to explore this code, and then you can contribute if you want. And also you can bring in your own algorithm and plug it in, and not worry about the operational angle to it or using the data. And who are the personas that will get benefited from using something like Startree? It's a platform and an experience that solves multiple use cases. Of course, our primary one is insights enablers who are trying to monitor those KPIs, whether it's system, business, or any other kind of critical, like user facing KPIs. You can monitor using our platform. You can also, if you're a data producer worried about data quality, data observability related challenges, you can certainly use Third Eye for that. And also, if you are insights consumers, like you are part of the business operations team or a product experience team, you care for your users and focused on driving business growth and adoption, you can also maintain critical or monitor critical metrics and identify anomalous events and take care or make some like qualitative decisions in terms of how you should close the gaps. I covered this, so I'm skipping the slide. Again, just to summarize how Startree can make your life better. Well, it can definitely help you to raise more profits by getting cost savings for your business. And you can identify issues much before than later. As an example, if you are into ad analytics and you're catching those insights much later, then you're literally losing revenue. Same thing applies for fintech or retail space. So you can catch those anomalous events much early, and unlocking the insights, you can fast track problem solving and save dollars, literally dollars in terms of. And we had use cases at LinkedIn where we were able to like save dollars in millions using Third Eye. So you can certainly do that and reduce risk and productivity gains. So with that, I will dive into demo. Just I'll pause for a second to see if there were any questions for me. If not, then I will dive into the demo. Okay, I do not see any questions, so let me dive into the demo and give you a quick walkthrough. So I think this is the most fun part. Now, all that I spoke, we are going to take a look at in action. So if you are going to use Startree Third Eye, when you land on uh, the landing page, this is what it is right now. The product is still evolving, and it's our very first iteration that we launched recently in the community edition. And we have also, as I mentioned, that self-serve analytics, that's recent launch, and you can pretty much access Treat Third Eye in these channels. And as we are evolving, we have plans to make this product more intuitive and very personalized to your use cases. So right now, as I was talking in my presentation, we have three core pillars, which is connecting to the data source, and then identifying those anomalous events, and then unlocking insights from those anomalous events. So that's how even our product is designed. So the configuration, which is mostly for people who are being admin of this platform, can use it, and not a lot of work they need to do. You can connect to data source very easily, and if you're using Startree platform, then that's all been taken care already. And if you're existing Pino users, it's super easy. if you're not a Pinot user also, you can definitely use the self-serve trial, self-serve analytics trial of our solution. And with that, you don't have to, like, in button click, you can spin up an environment and then start using start read third eye by working with the team. And you don't have to do anything, all is already set up for you. We just plug into your data source and then bring those data. If you have critical metrics in your data sets, that's already pulled into third eye, you don't have to do anything as a user. We have alert templates, which is the pre-configured templates that I was talking about. Today we support statistical detection template, and we are also, in future we will be adding more ML based algorithms to this. And as I was talking about, you don't have to write any code. These templates are already pre-configured for you, and you can plug in those templates and start using that. We have also something called a subscription group, because once those anomalous events are identified, I'm sure you will be interested to see them as a part of your Slack channel, or as part of your anomaly, as part of your email, or you want to see as part of your say another like communication platform. You can connect to any webhook. So we support webhooks, and you can connect to webhooks and connect to your custom communication platform and see those insights there or anomalies there. And you can also schedule this at a certain time. All that is done at a much easier experience, and it's all no code experience. So you can click here and create subscription, and you can select which is the communication mode you want to go after, and then subscribe to those alerts, pre-created alerts. And then we have something very interesting called events. And this is where I want to highlight this more, because we are talking about unlocking actionable insights, and events are one of the key parts of it, besides the dimension drills that I was talking about earlier. So, what is events? Events is a framework that this Starry Third Eye provides, and it's a very flexible framework where you can bring in holiday data or any custom events that would have caused your drop in critical metrics. As an example, as I was talking about earlier, the drop in page views, if you see that, and then what would have caused the page view drop, and if you're trying to correlate, it could be sometimes, as we were talking about earlier, like Christmas time, if you're managing like product which is more consumer facing, and there's a spike in terms of number of users coming, and you may run into issues if you are not scaled to handle that. And using third eye, you can bring in those holiday events early on, and then correlate if the spike is because of an increase in traffic, and you can predict that early on, based on, okay, around this time, this is what may be expected growth, and then you can proactively work towards that by correlating the events. Even in real time, you can see that if something went wrong, like in terms of you rolled out a pricing catalog for your end users, retail users, you're buying products from the company, and that caused like driving away your users from using that product, then you would be wondering why that is happening. And in a large company, it's so hard to answer if a group of people only managing a platform like this or a product like this. And using those events, custom events, you can bring in those pricing changes as well, and you can correlate and identify what's going on. And the beauty of this framework is you can bring in any kind of data. We have metadata. You can update and correlate and unlock those actionable insights. And I'm going to show that now. So this is all about the configuration, which is very easy to use and set up. I just wanted to cover this to give you that now as a user how you are going to use this product. So let's take an example. So if you are a user in the retail space and you have a order data set that you are monitoring closely, and these are the sales orders that are being sold, and you are monitoring the order volume in a day-to-day basis. So let's dive into creating an alert like this. This is an existing alert, but I will give you a real walkthrough of creating this alert. So I will go to create alert experience, and let me go to the home page, and you can always go to like viewing existing alerts also, and you can also pick up one of the existing alert and clone it, or you can start from scratch. So the create alert experience has two different types of view. We are supporting advanced users and also simple view as a simple user. Right now, I'll give a walkthrough of advanced user, which is like low code. Simple experience is no code. So in the even in the low code experience, you don't have to do a lot. We have a recipe book, so you can always look at that and then start using it. For now, I will copy paste one of the alert templates I had before, and the way I will use this low code experience is I just have to give the template name over here, the data source name, data set name, the metric that I'm going to monitor. In this case, the order quantity, and trying to monitor the order volume. I'm looking back for my seasonality period over the 7 days, and look back period of 128 20 days, so that I'm training the model accordingly to look at patterns. And Startree ETS is a upgraded version of Holt-Winter algorithm. If you're familiar with Holt-Winter algorithm before, so how it helps is any kind of alerting mechanism. First thing comes to our mind is how I can set a threshold and start monitoring. But the challenge is if you are monitoring KPIs or metrics, and that has a trend and it can have shifting trends. And if you are using just a simple threshold based alerts, then it is not, it might turn out to be noisy at times, because the metric might have spikes or it might be changing through a trend. So using Stratry ETS, which is an upgraded version of Holt-Winter, it self learns those metrics patterns and try to predict the predicted value and the window in which, the upper bound and lower bound in which it is expected to perform. And anything goes beyond that, you are able to catch those anomalies. And we have given all those knobs to user to adjust that, to get to the right alert configuration that you will be interested in, so that you can get accurate alerts. And this is the part that I was talking about, that how third eye is enabling accurate alerts and finding the accurate anomalies that you should really care for and look for to unlock the insights of what's going on. So in this case, I entered the data. Now I before creating the alert, I can play around. I can just click on the alert preview. This is an old data, so I will go back in time and look at what's going on. So as you can see, it already plots, and you can see how fast it is. It's all happening in real time, and it's running queries against Pinot, and then bringing in this large data set recently loaded, or I refer to, and finding all the anomalies in here. In this case, you can always zoom in to a certain area and see if those looks good, and you can also point to that, and it shows what is predicted versus actual value of the orders that are being placed, and when this anomaly happened. And why this is pointed as an anomaly, as I was talking, it already learned a pattern, the predicted one you see in green color or the dotted line. And we have also upper and lower bound, which is automatically learned by the model or the algorithm. So it plots that, and any time, in this case, the order volume went up as part of the, as compared to the predicted value, and the automatically detected upper and lower bound thresholds. So that's why it's identifying an anomaly. And in this case, you can also do like, for example, if you do not care for like too many anomalies, you can always lower the sensitivity. If you are a person who cares about every anomaly that has been found and you care about, you can always increase the sensitivity, and you can reload the page and see if there are more anomalies. So this way you can adjust, and if you want to be have your alerts be noisy versus not noisy, you can adjust all of that. Now I'll quickly create this alert and show you how quick it is to create this alert and identify the anomalies. So as you can see, the alert has been created, and I'll just go ahead and refresh this page, and there are anomalies created also on the background. So you can see those anomalies that are generated, and you can click on them and see, view what are those anomalies. So for now, I will dive into another like alert that had more interesting anomalies, and I will give a quick walkthrough of that. So when you click on that, you can see the list of anomalies, and if you are interested in a particular anomaly, you can always go there and view that anomaly. So I've already found an anomaly that is interesting, so I can click on that, and then I can go to the anomaly piece. And this is the interesting part that is going to unlock the insights to make it, or unlock the actionable insights for you, so that you can take necessary action, and then you can go and solve for that. So in this case, I'll quickly talk about what this anomaly view looks like. So as you can see, this anomaly that has occurred, and I can always hover over this and then see, in this case, we have number of orders that are predicted versus the actual number of orders. And you can see in this example, the predicted value is higher, like the model or the algorithm predicted that we are expecting more orders around this time. However, it's only predicted a couple, like, which is 19 in this case. Now guess what, if I am not going to say I'm not going to identify these anomalies in a timely fashion. Say, for example, this is happening on 29th July, around that. But without third eye, if you're not able to detect those anomalies in real time, and you're detecting after a couple of days as a reactive mode by watching some dashboard or somebody told you, by then guess what, from this time to this time, there have been this anomalies going on, and it could be associated with this drop, revenue loss for you, and you might have done something that would have caused this drop, and you do not know, and you're learning it much later, and you can easily guess how much money you will lose during this time. In this example, if I quote, like, per order, if you're spending like $100, and you're identifying, like, say, after 5 days, then you're kind of, per day, per order, you are losing almost $500. And if in this case, if your predicted data was almost double, that means you're losing like almost like 50 to 100% of your revenue that you would have expected to gain in during that period. So this is definitely not good for your business, or any if you're monitoring system KPIs also, I'm sure this is not healthy. So using third eye, you can catch this much early and mitigate the risk of like loss to your business, or productivity loss, or cost that you might have incurred in a late detection. So now once this is detected, is that enough? No, probably not. Then the next part is how I can quickly unlock those insights and see what's going on. So I'll click on this investigate anomalies and try to see what's going wrong here and why there is a drop, right? So I can come down and you can see there's top contributors, which can give you a good indication of what might have contributed to this drop. You can always do a look back period of 1 week or 2 week or 3 week and compare your baseline with the like the actual value, and then see what's going wrong and why something going wrong. I'll dive into the heat map because this is probably something that everyone is interested in looking at when you're monitoring a KPI. And in this case, I'm monitoring the order volume drop. So I'm interested in knowing what would have contributed to that. And there are several things I can see in this insight. It's a sales order data. You see what products are being sold, what sales channels through which these products are sold, and the sales region and store location, and there are a few other dimensions. In this view, you can see that there is a huge drop in sales channel for in store, while distributor, online, and wholesale are doing okay. The rest of the dimensions are doing okay. I mean, in terms of color coding, the blue indicates an up, like increase, and then the red indicates drop. It is very contextual. In this case, order volume, it drops, it's not a good sign as a user, and I'm worried about that. But if you're monitoring, say, a site speed, and if there is a drop in site speed, it's a healthy, in fact. But if there is an increase in site speed, it's not healthy. So using this, it's pretty flexible framework, so you can draw the heat. I mean, you don't have to draw the heat map, we do that for you, or the software does that for you. But you can see how quickly those insights are derived, and it also tells you what is the contribution and what was the change. So in this case, in store, there was a huge drop. So let me look at if this was the case 2 weeks back. So I can, this is week over week insight, so I can go back and increase the 2 weeks back. Interesting. So in 2 weeks back, if I look at the in-store product, or the orders were doing fine, in fact. But something has really happened in the past week that has caused this huge drop. I can further drill down and look at what's going on within that dimension. And looks like this not something very interesting. I can see everything is doing fine. That means some other thing might have caused this huge drop. So this is where the events come into play. And I'll quickly look at if there are any interesting events that might have contributed to this drop. So when I look at these events, okay, I see there is a pricing catalog change. Now let me plot this and see if there was an overlap with this drop. Great. As you can see here, the pricing change, or the change, the catalog change, has actually contributed to this drop, because it started, the catalog change was running for this duration, and that's where I see. And once that catalog change has been fixed, it has picked up and it is doing fine. So if you are looking at something like this kind of insight, you can also correlate. This is what the events framework I was talking about. And you can correlate the events and identify what's going wrong and why something went wrong. And as I was saying, this is pretty flexible in terms of bring your own events, and you can plug it in and then correlate with your drop. And in this case, since there's a pricing change, I will go and reach out to my um, like business operations team or the pricing team who have made this change. I'll quickly talk to them and try to take care of this. So maybe that they were trying out some pricing changes that didn't work well or fly well with the end users. There was a order drop, so it's a meaningful insights, so they can make a decision about whether to go after that new pricing model, or they have to revisit their pricing strategy. So they can make decisions by using this insights that was unlocked from this anomalous event. So yeah, this is what in summary, if I have to say, like, heat map and the events and the top contributors is helping you as an end user to unlock those insights, and built on top of Startree Cloud and the managed Apache Pinot, it is making super quick, and you can catch anomalies in real time, so which is very intuitive and and very helpful for you as an user. And if you're a decision maker, or you're enabling the decision maker to be successful, you can do that. And besides, also, as you saw, it's so easy to use as a developer. If you're trying to support a platform like this, you have less overhead, you can focus on just problem solving. You can also by the way, I forgot to mention that this product also has APIs that you can use, and you can build custom apps on top of it, and just use those insights and show it in your custom apps. Like, as an example, if I have to say, Becky was showing Disney Genie earlier, and if she wants to monitor those outliers and the users who are looking at the schedules, and if they find something anomalous and we want to show the users and alert the end users, you could also do that. And you don't have to change your experience, you can keep your experience as is. You can use the APIs of this platform, and use that to show those anomalous events or the insights that could have drawn for those anomalous events, and the users could take action. As an example, the wait time, like if I'm interested in seeing some particular event and I'm waiting in the queue, and I want to go to the other event, I'm in the waiting queue, but if there's an like increase in traffic, and no, you can't see this today. So if I can be notified about that, that would be so awesome, and then I can plan my day more intuitively. So you can improve the user experience even using this platform. So that can be very much doable. So with that, I will go back to my slide and try to quickly talk about the key takeaways that we got to see from this presentation, which is went through why it is important to unlock actionable insights from those anomalous events. So primarily to fast track problem solving, and understand the impact to your end users, and how you can mitigate risk, and how you can prevent like any impact to your business in terms of revenue or growth. The second one is how Third Eye empowers users like you to solve for multiple use cases at ease, scale, and with accuracy. So you can use this platform and enable your end users to be successful, and yeah, and unlock actionable insights to make meaningful decisions and qualitative decisions, which is more important. With that, I want to share a quick note. If you're interested in trying out Startree Community Edition, is completely free to use. And as I was saying, Startree Third Eye is source available. So if you want to explore and learn, you can do that. I have the QR codes. If you're watching this, you can take a picture of these QR code and get started. And also you can download the community edition, talk to us. We have a community there. We have now recently launched a sign up for 30 days free self-serve SaaS trial, which enables those analytics like insights at a faster speed, and you can ingest your data to Apache Pinot platform, which is managed through Startree Third Eye. You don't have to worry about how to spin up analytics platform, how to run with it. It's all self-serve, and with few clicks, and then you can use Third Eye also, another way to look at if you do not want to go through the community route or explore the code. So yeah, with that, my talk is I'm going to wrap up, and thank you very much for listening to me. And I hope you have found this useful and it's valuable to you. And I hope I will see you in our community very soon. And if you have more questions, yeah, we will have a panel later. But you can also contact me on LinkedIn. I have a Twitter account. You can reach out to me on Twitter. I produce a newsletter every month talking about overall like data products and AI space and interesting topics. And I run AMA sessions. So if you are interested talking at my session, also reach out to me or subscribe to my newsletter. Okay,
Wow, thank you so much. It was a great session again. It was nice and interesting, and the most interesting part for me was that you basically provide a working solution to end users as well, and not just and I can feel it's not just for business customers, right?
that's correct. Developers can use it. It's built for everyone.
Yes, and it's really nice because there are not many solutions that are so ready to use and that's developed by you. So
And using this platform, we have kept in mind like developers who want to be more explorative and advanced and try to use this for technology advancement. And also the end users who are not a little far from using the data, they can also get the benefits using this platform.
and this is really, really exciting. And I think we will have a lot more questions during the panel. I think with that, I say a big, big, big thank you again for your session. And I can't wait to have you back at the panel. And I hand over the word to Håkan.
Thank you.
Thank you. Thank you. Thank you, Madamita. And now we're going to introduce our third and final speaker here for this evening, Priyanka Shaw. And Priyanka is a Microsoft MVP in AI. She's also the head of AI and IoT in Southeast Asia. And she works with AI strategic business leadership, and she is a solution architect for data science, artificial intelligence, machine learning developer, an innovation lead, and a public speaker and blogger for AI and ML, and especially with respect to Microsoft technology stack. So that's a lot of things here, Priyanka. And I also know that you're also talking a lot at different conferences. So what was your last session?
Last session was, I think, for sustainability. Again, Microsoft launched this Microsoft Cloud for Sustainability. So there's a lot of interest in oil and natural gas sector, utilities sector for recording, reporting the greenhouse gas emissions. So last time around, we were educating various businesses around how to use the Microsoft Cloud for Sustainability to reach their carbon footprint and ESG goals.
Yes, and actually sustainability is also the topic for your talk here today, which is a really both relevant and also very important, really important topic here. So so before I give you the stage here, I would just like to say here that if you have any type of question, you can just post it in the chat, and also stay here with us, because even after this, even after the Priyanka presentation, we will have a panel debate where you can ask any type of question here too. So with that said, we will leave the stage here to Priyanka. Actually, Priyanka, I forgot her. Maybe if you could share your presentation.
Yeah. Yep, I'm sharing my screen. Yep. So hello everyone, thank you for joining, and we will be discussing about energy analytics and AI for sustainability. So how they go hand in hand, and while we are on this topic, we will also see a lot of interesting things about digital twin, and how that.
Yeah.
Yes, how can you want to say
Priyanka,
something?
yes, Priyanka, we see your sort of speaker slides or something.
Oh
If you
wait,
just
hold on. I think I need
yes,
to switch the swap. Yeah, is this okay?
yes, that's fine. And also, if you could just
Okay.
remove that thing there too.
Yeah.
Yeah, thank you so much.
Oh wait, I closed my presentation, I think. Are you able to see my screen still? Yeah, okay.
Yes,
All right. Yep. So yeah. So today, as I was saying, right, we are going to cover about real life machine learning, and especially centered around energy analytics and AI for sustainability. And while we are on these topics, we'll also see some interesting concepts about how digital twin can actually help us with all of these energy analytics, and consequently reducing the energy consumption, thus helping us achieve our sustainability goals. So I think Hawken did a awesome job for introducing me. So I'm not going to spend a lot on this slide. Yeah. So this would be roughly how this session will run today. So we'll have an industry view on data and AI in manufacturing. We'll introduce about digital twin and what is actually energy analytics. Like, what do you do? Do you bring down the greenhouse gas emissions, consumptions? So what is it which we do in energy analytics that helps you in reducing energy consumption, electricity consumption, and consequently reach your sustainability goals, right? And then I'll concentrate on the very specific case study which we did for one of our fragrance and oils manufacturing client, and how we actually helped them. So they were a very boutique firm, very small firm, and how we enabled them to record their energy consumption patterns and gave insights. Right. So and of course we'll have some interesting demos, some Microsoft related digital twin reference architectures. So I have shared two YouTube links. Please feel free to refer to those, and that will give you some sort of insights into what a digital twin is capable of. And then at any point of time, we are happy to take questions, right? So first, we'll look at the industry on data and manufacturing. So why all this noise around manufacturing sector, especially? So we talk about telecom, we talk about other government sectors, but what is about manufacturing, and why modeling it or doing analytics in manufacturing sector is such a challenge? So it is because industry 4.0, with all the data platform modernization, digitalization, was defined in 2011. And then there was IoT investment also in 2015. AI came around, like almost half a decade ago. But then smart factory still remains this dream for many industries, right? So be it automobiles, be it your beverage manufacturing, be it your plastic manufacturing firms, be it small, energy, or as in our case, fragrance manufacturing firms. So the smart factory is still at a very conceptual level. Okay, so we have taken example of three sectors. So in the climate sector, which is of course the forgotten sector. So as I said, companies are now getting up and then sort of realizing that emissions are a serious problem and we need to tackle this, and which is why a lot of advertisement and noise around a lot of sustainability products platforms. Okay, so yeah, so in the climate sector, there is 22% of emissions of greenhouse gases, and then 29% when indirect energy is taken into account. Indirect meaning, let's say indirect consumptions where the employees are using vehicles for transportation, the electricity which you purchase, the amount of water which you use. So this kind of indirect energy also, right? Then productivity, if you look at that for a manufacturing sector, actually the productivity has slipped. So as you see, it has been in the negative since the year 2004 up until 2017. And even though there's a lot of spending, right? So you see there's almost more than 200 billion euros spent in manufacturing. And then there are a lot of providers targeting the smart factory paradigm, but then most of the efforts are in a none of them are actually realized or released on a big scale, right? So what is the issue, right? So what is that missing piece which enables which has not enabled the manufacturing sector to actually be smart and connected like many of our other sectors, correct? Because the problem is how manufacturing data is viewed, right? So see, the thing is, it is manufacturing sectors are not very agile because they have this data from decades. Okay, so there has been a lot of evolution of industrial systems also. It was all manual, then there came ERP, CRM, then there came digitalization, there came cloud, right? So they had to go through this transition, and as a result they have a lot of disparate systems. They have a lot of data which has accrued over the decades, and that data is very complex, right? I mean, you don't have a very homogeneous stack like an ideal software stack where you have connectivity. You will have a data lake like a central data store, and then you will have visualization, analytics, AI, machine learning, predictions. So this is the ideal view of the manufacturing data. But in reality, the manufacturing data is scattered all over the place, right? So you will have production data, you will have some new manufacturing systems, you will have logistics and maintenance data in probably some legacy systems, right? And then you will have some quality data which is probably not even logged properly, or could be in systems like SCADA, or some crude sensors with the help of Arduino chips or Raspberry Pi, those kind of things, right? So a lot of data is, the data is not homogenized, and there's a lot of systems at play here, which is why it is very difficult to address the smart factory paradigm here for a manufacturing sector. And then add to that AI/ML to the mix. So what happens is a lot of solution integrators, they play the AI/ML card, saying, yeah, AI can tell you how your equipment downtime or your equipment part maintenance time, we can foresee into the future, all these fancy things, right? But if you look at a factory altogether, it is an aggregation of various machines. So an AI/ML model probably will address only one machine or a part of the machine. So let's say if I'm talking about an air conditioner, then probably just the compressor of that, right? Or if I'm talking about probably my computer, then one small part of that could be the CPU or could be the memory. So one aspect of that can be modeled using AI/ML, but manufacturing is different. So as you can see, right, so I can predict for one engine, but a manufacturing facility itself is a collection of so many different types of machines here, as you can see. Okay, so because of these things, even simple products, they involve hundreds of machines. So you can have, like, in a, like, manufacturing, typical manufacturing setup, you will have so many. So if you take example of oil and natural gas, and you have oil drilling, you will have the oil wells, the oil field itself, so many things to model on, and so many things to do the forecasting on. So the problem being, which with such disparate data, how do you succeed, right? So how do you achieve this smart factory paradigm, which is what we have to do by standardizing the data. So in a typical manufacturing setup, what are some of the common problems which you face? What are some of the common metrics or KPIs which you want to measure? What are some of the analytics which you want to drive out of your derive out of your data? Okay, so for a manufacturing setup, the most important part would be the cycle time, right? Like the cycle time, the start of the manufacturing, end of the manufacturing, the product line, monitoring. Okay, there will be part maintenance. What part of the equipment, what part of the facility needs to be maintained? Machine downtime, how long is the downtime of my machine or my asset? Okay, defects. Okay, so what part is defective, what part is close to being repaired or maintained. Okay, and then that is why we need to twins at many levels. We need to build the twin at the machine level itself. Okay, then the production line level. So production line could be a aggregation of many other things, like for example, if you want to have manufacturing, then you could have fabrication, washer line, scrap disposal. So the production line itself you need to model. Okay, the entire facility. Now an entire factory could be a collection of many production lines. So at a machine level, like individual machine level, you need to create a digital twin. We'll come to what is a digital twin, right? But then yeah, by building up real-time digital twins, we need to have a twin of the machine, the thread, the production line, and the entire factory itself, right? And then on top of that, we will have analytics. So you can have some visualization, like what is the actual yield versus predicted yield. What if the downtime was 2 hours instead of 1 hour? What could be the potential issues? What are some of the forecasted part maintenance? So when is this particular machine, or when is this particular equipment, or when is this production line going to need maintenance in the future, and how to plan for an optimized yield, or how to reduce the bottlenecks, how to reduce the scrap. These are some of the analytics which you would want to extract out of it, right? Even what is the optimum packaging of the product. So there's this very interesting case study which was done for one of the candy manufacturing. I won't take the name of the client, but candy manufacturing, wherein they wanted to ensure that I package. So we have this typical candy, right? Like you have your M&Ms and your Skittles. Okay, so how do I ensure that per packet I am packing around 90 grams or 100 grams of product? So which is needs a real-time manufacturing of that production line, right? Especially the packaging, the end product packaging. So these kind of things, these are the analytics which a typical manufacturing setup would monitor. So I mean, I'm just talking of one aspect where we are talking of the final weight of the product, the amount of number of candy which is put into the package. But yeah, I mean, you can imagine that right from starting the production, like what is the raw material pumped into versus the final get. There are so many aspects which could be digitized, which could be monitored, and from where we can get insight. So in the demos which we will see, right, we will see how interesting it can get. So right from the source, so right from where the raw material is arriving in my factory, to the end user, like I might send it to retail outlets or businesses or consumers, end users. So till that point, we can actually build this smart factory construct, and then be able to have real-time insights into each and every step of the operation. Okay, so when we look at manufacturing, right, so what is the manufacturing value proposition? So value proposition is not only the facility, like not only just having the a smart manufacturing or connected factory, but also workforce empowerment, right? So for example, safety of workers. Okay, and then having the workers effectively share their skill sets together. Okay, and operational resilience means like for example, proactive part maintenance, and then integrated the front and back office solutions, remote working options, and then finally organizational agility, which is again having sustainable innovative production. So connected and intelligent IoT for smarter products and services, and then ability to innovate at scale, okay, with agile and secure solutions. So these are the three pillars of manufacturing value proposition. And then this is how a smart factory, a factory of the future, should technically look like. So if you really talk at AI for manufacturing, right, there are these three things. So AI for manufacturing targets at building more agile factories, creating more resilient supply chains, and then actually transforming our workforce. So agile factories meaning automated quality maintenance or predictive maintenance, so without having to manually intervene or manually go and actually inspect each of the equipments or facilities, the AI should be able to proactively trigger an alert or trigger some sort of message for predictive maintenance or quality inspection, or also alert in case deteriorating in advance, I mean, before it reaches the end time or life cycle end and there's a need to fix that, it should be proactive. So that saves overhead and manual intervention as well, right? Creating more resilient supply chains, meaning our typical supply chain optimization, right from where the product comes in, right? So right from where your source material is, raw material is procured. So entire supply chain, end to end optimization. So be it your transportation routes, be it your inventory management, be it your warehouses, storage, all of that, optimizing all of that and providing insights into that. And then transforming your workforce is worker health and safety, process and workflow improvement, and increasing the work productivity, right? So for example, I need not come on site always to inspect my production line. By the help of our virtual environment, by digitalization, by smart factory, I should also be able to remotely monitor my equipments and be able to transfer my skill set. So sitting in probably Singapore, I should be able to monitor a factory somewhere halfway across the world, and if someone is working there, I should be able to guide them, right? So that sort of a ecosystem, a connected ecosystem is targeted by transforming the workforce with AI, right? So some of the examples where we where we have seen this implemented already. So as you can see, Shell implemented worker health and safety by proactively identifying your hazards. Okay, so they have installed video analytics on nearly 44,000 of their Shell petroleum stations. Okay, and to proactively respond to safety hazards. So they are using computer vision and machine learning at the edge to do these things, right? Again, if you look at the GE, then they are actually the aviation group of GE. Like whenever we are boarding a flight, right? Prior to that, there has to be a lot of due diligence done, correct? So they have to check all the parts. They have to check, if all the seats are secure and there's enough supply of your oxygen masks and life jackets and other, plane hygiene and parts quality check and those kind of things, right? And there are a lot of disparate systems to do these kind of maintenance, in flight performance and stuff. So which means it's a bit of a waste of effort and time from all these systems. Like some system is tracking your flight hygienes, other system is tracking your part maintenance and performance and fuel efficiency and all of those things, right? So instead, if you had to have a central system, a digitized system which could do all of that, so it should be accurate, and the reporting should be efficient. So it can do everything right from the individual aircraft to the ground staff to the cabin crew and all of that, right? So from the component level to the flight to the cabin crew to the flight crew, all of that should be audited, and then the insight should be presented at once, right? So all of these, like some of the interesting aspects what could be achieved by smart manufacturing. So I won't go into the details, right? As we already talked of predictive maintenance. So predictive maintenance meaning identify which parts are required to undergo maintenance, or then detect anomalous maintenance patterns in real time. Automated quality inspection also follows the same thing, like enable insights, real time insights. Okay, and then automatically trigger alerts if there is deteriorating quality, either for product parts or equipment or the final product yield. And as we had discussed about supply chain optimization, process workflow improvement, so some of the other names and tangible savings which they have actually achieved. So by doing all these process improvements or by predictive maintenance, companies have actually having actually had savings, so projected savings of around 50 to 20 million globally, right? So some actions which you take, even though they might seem not so how should I say, efficient and not so cost effective at this point of time, but then as it accrues over the future years, you can see there will be substantial global savings, right? And on top of that, so not only just making your manufacturing smart but also sustainable. So we have this ESG goals, right, which is environment, social and governance. So environment is sustainability, social is people centric, and governance is it has to be secure and compliant, correct? So in this ESG paradigm also, this smart manufacturing has to fit in. So when we say energy analytics, right, actually, so smart manufacturing boils down to energy analytics. Within energy analytics, we have like identify the energy and cost intensive processes and equipment. So which part of your manufacturing is actually consuming a lot of energy, right? And then what are some of the consumption patterns, like probably does it consume a lot of electricity and on certain days, okay? What is the yield on certain days when it consumes a lot of electricity? Then we can also map an emissions, calculate the carbon footprint, and then have analytics to optimize the process and equipment. So where is the bottleneck, what is the production volume, what is the scrap generated, can there be anything to prevent this, or to prevent the downtime, to increase the asset uptime. So all these kind of analytics we can do if we have a real time monitoring, or real time insights into what sort of how should I say, so what sort of consumption patterns of the machines, or what sort of operating patterns of the machines are observed, okay? So to do all of these, right, I mean, talking of all of these things seems very wonderful, and then the smart factory really lights you up, like, okay, this is what I want to do. And this typically happens with a lot of the consumers whom we talk to, right? So they have these wonderful ideas about like I want to reduce my plastic waste. So if you take example of bottling industry groups, right, like beverage manufacturers like Pepsi and Coke and stuff, so they have this huge manufacturing plants, and they have very ambitious goals of reducing the plastic waste, reducing reducing the emissions. But then how to go about it? Where do I install the sensors to monitor my production line? What data do I collect? Okay, how do I map my electricity consumption? What sort of what aspects of my entire production line do I monitor, like right from the start, right? So there's fabrication line, and there is packaging line, and there is scrap disposal line, and all of that. What is the maturity of my data at each of these constituent processes? So all these kind of things is what we need to address, and this is what exactly is done by digital twin, okay? So digital twin is a digital replica of your physical systems. And by physical system, we don't mean like, so let's take an example of again a bottling manufacturer, okay, a bottling industry group, beverage manufacturing giant like Coke, right? So now if we wanted to create a digital twin of one of manufacturing plants of Coca-Cola, then what it would look like, a digital twin. So the digital twin would have a twin of all its supply chains, like from where the material is coming. In case of our beverages, it is water, of course, the main raw material. Then constituents like your sugar and preservatives and carbon dioxide. So all of that, so raw material, so the supply chain from where we are procuring the supply chain. So we can make a digital twin of the supply chain itself. Then digital twin of the actual production line from where your bottles are manufactured and your product is filled into the bottles and packaging. So all of that. then within one particular facility, within one particular factory, there will be like probably 50 production lines. So each production line will have its own digital twin, and I can monitor all of them in real time, like which production line is doing good, and what is the optimum yield, and why this production line is stalled, and why XYZ production line is not manned, or what should we do if it is unmanned, and what part of the process, which part of the process my current bottle is in. So all of that we can monitor, right? And then we can create a digital twin of the factory itself. So factory meaning the workers in the factory, the areas where we need to have a lot of human interaction or intervention, as compared to areas where it is dangerous for human beings to be there, and then trigger alerts at real time if workers are too close to the production line, workers are too close to some, I don't know, physically dangerous aspect like a furnace, for example. Yeah, so all of these things we can have a digital twin of that. So whatever is in your physical world, whatever you want to monitor, could be consumption, could be your product manufacturing process, all of that you can reflect into your digital world, and that is called as a digital twin, right? So as I said, it could be a component, it could be a system of components, and it could be a system of systems, right? So it could be like an enterprise digital twin. Or maybe if Coca-Cola has hundreds of outlets all across your geography, then yeah, we can also create a digital twin of all of those constituent factories of Coke, and yeah, that could also be like enterprise wide. Okay, so in digital twin for manufacturing, what are the actual savings we get, right? So we actually have 10 to 15% improving the asset utilization, increasing the production volume, actual up to 20% reduction in waste materials, 3 to 5% increase in the yield and quality, and reduction in operations cost, of course, because all of that is real time and digitized, and proactively monitoring for maintenance or setup time. And of course, once your energy consumption is reduced, once your energy usage is optimized, then it will result into greenhouse gas emission reduction, right? So consequently, once you take care of all of these things, the end result is reducing the greenhouse gas emissions. So if you look at the anatomy of an intelligent factory, first we discover like what are some of the key things which I want to observe. Okay, so as a bottling industry, what are some of the key measures which I want to for example, achieve? So I want to reduce my scrap. I want to probably look into where the bottleneck is. I want to see, which machine is very energy intensive, and how do I maximize my output. So these are some of the key failing KPIs which we first need to observe. And then how do we monitor? Like, how do we monitor the data? How do we monitor electricity consumption? How do we monitor equipments, machine, start time, end time, cycle time, right? Productivity. Sorry. So for that, you need to actually install the sensors, right? So where to install the sensors? At the start of this production line, in the middle of the production line, on the top of these machines, at the end where these people are packaging. So where are to install the sensors? What type of sensors? Should it be AI vision cameras? Should it be GPS tracking devices? Should it be your normal RFID RFIDs? So these kind of things, like type of sensors and where to install the sensors. So once you've identified the KPIs, what makes more sense for you to optimize, what is the business value proposition for you, then we actually need to make a decision about the type of sensors and the location of the sensors, and then start collecting the data. Again, the real pain point of installing these sensors and collecting the data is not as easy as it sounds, right? Because typically, to make any kind of analytics on top of the data we collect, we need to have amount of data. So maybe if I'm installing sensors for a couple of months, that is not going to give me any insights. Plus sensor is to be modeled. Okay, so when I'm saying that I'm actually logging energy consumption data, energy in amperes or power in kilowatt hours, right? So most of the time I have, for the first initial, few days or few weeks, I'm going to have a lot of junk garbage data. I need to carefully study the data. I need to carefully pattern the data, and make a common data model, and then actually get some meaningful data recorded. So it's not a very easy process, right? So before we do any sort of analysis or recommendations on top of the IoT recorded data, we have to shape the IoT data itself. And there is going to be a humongous amount of data. There's going to be data from equipments. There's going to be data from your vision cameras in case you want to have a 3D, insight into your production lines, right? And finally, we deploy that, and then we identify new use cases. So it's not like a big bang approach. We go to people, we ask them, hey, Coca-Cola, what is your problem, and can you please list down all the laundry list of your defects, and I'm going to build a digital twin for you. No, it doesn't work that way, right? We have to break it down into parts, and then we have to actually address few of the KPIs and then slowly scale up, right? So that is how it will help to address, actually, like, bring value to the businesses rather than going in and trying to solve all of their 100 problems at once. So if you look at this intelligent factory architecture, right, it would look something like this. So you will have to install sensors on all of, like, could be vision cameras, IoT sensors, back office, some external sources like SCADA, CAD CAM drawings, and all of that. And all of that will be ingested into your Azure IoT Hub, and then modeled using Azure Digital Twin. And then you will have analysis, right? You will have real-time analysis, what you call as hot analysis. You could have some operational analysis like time series, right? Like time series chart of your production yield. Okay, then you could have some operational code analysis, which is operational and unstructured. So like, for example, data which is in your database or in your data lake. And then on all of these different types of data, you could have your AI modeling for forecasting, for recommendations, for other insight, AI powered insights, those kind of things, right? So finally, I mean, these are the stages in which you will power your intelligent factory. What are some of the, intelligent factory reports, how they look like? So you could have 3D diagrams. So these are typically done using Unity software or 3D scenes in Azure Digital Twin. So we can actually construct a 3D diagram of your production lines. Okay, and then you can have certain, metrics, like, for example, what is the asset uptime? Okay, what is the total giveaway? And so let's say, for example, this is, I'm monitoring 3 production lines here, production line 1, 2, and 3, and then I can see some alerts here. So what is going on as compared to the other 2 production lines, and that is highlighted out to me. So I know in real time that something is wrong, and I can try to zoom in and see what is wrong. So as you can see here, right, the rolling pouch average. So for all the 3 lines it is given, and if it is, there are some anomalies, then that is highlighted over a period of time. So as you can see, right, you have a possibility of what you're doing in your physical factories. You can have actually the same exact mirroring in the digital world. Advantage being, you can monitor it from anywhere, you can monitor it real time, and you can get access to all of the history. So let's say at some X point in time in history, what was the condition, temperature condition, who was present, who was physically present to monitor that line, what state was my product in, okay, was it packed, was it unpacked? All of that I can analyze historically, because all of that will be available as data stored in my system, right? Yeah. So, and it's not only manufacturing, right? So energy analytics, for example, here in the case of a cheese manufacturer, so how typically, they identify few of the use cases. So like, as I said, right, we don't actually address the laundry list of everything. So we actually zoom down into typically 2 or 3 top use cases, topmost concerns of a particular client, and then help to address those, and then slowly scale up. So the business challenge for this particular cheese manufacturer was that there was no real time visibility into the energy intensive processes. So what are my energy intensive processes? So all of the utility sector, energy sectors, they have this huge golden goal of reducing emissions, but or reducing their energy requirements. But then how do you know where to reduce the energy? Because there's no real time visibility, right? Which of my processes are energy intensive? So lack of visibility into that, lack of raw material consumption. Okay, and then a lot of variance. So even if on some days I give you 1 kg of 1 liter of water, but that produce 1 liter of milk, that produces probably 500 grams of cheese. On other days, some good days, I can get probably 800 grams of cheese. So why this variation? And then identify the excess, the waste, and all of these things, right? So then how we solution it is, our use cases is, first of all, enable real-time insights and monitoring into critical machinery. Okay, so what is processing the milk and giving the final output? Okay, so identify 2 or 3 points where we can install sensors and collect the energy data, right? And then inventory management for raw materials, because raw materials consumption is also one concern, right? So inventory management, how much raw material is coming from where, how much of it is spoiled versus how much of it is actually ready for use during the manufacturing, and how to address the supply chain issues, these kind of things, right? And then finally, once you address the key points, some of the value delivered is quickly apparent. So for example, 6 to 8% energy savings, and once the energy is saved, which means your cost, your operational cost will also go down, right? Your equipment will be the uptime will be more, and there will be improved visibility. So these this is the incremental way in which we drive these kind of solutions. Okay. So typically, the project which we are going to talk about today, the solution, which we solution real time for one of the boutique fragrances manufacturer, flavors and fragrances manufacturer was, again, they have installed IoT sensors on probably 100 of their machines. Okay, actually, like, this is an actual case where the poor client had installed equipments on hundreds of equipments, but they don't know what to do with the data. So right now they are in a position where they are able to actually calculate and see, like, this is my energy in amperes. So the electric current which we get, right, it is measured in a unit which is called as amperes, right? And using some statistical formula, by the help of statistical formula, they are able to calculate the power consumption in kilowatt per hour. So I have my electric current consumption per machine. Okay, per machine, I gathered that data, like, not I, meaning the client has gathered that data for over probably couple of no for a couple of years, yeah, but they don't know what to do with the data. That this data is not telling them any story. Okay, so which is where we pitch in, where we come in. So for example, currently the consumption in amperes and the data is stored in Google Cloud, and there is a formula which is applied to that ampere data to calculate the power consumption in kilowatt per hour. So per equipment, right now I'm getting to see two graphs. One is the electricity and the power consumption. But what does that tell me, right? I mean, how do I derive insights from that? So the the scope here is the current this is the current thing, right? So they have IoT sensors installed on their equipment, and we are getting the energy data, okay, which is amperes and the power consumption in kilowatt per hour. Okay, and there is some production data, like, how much product was produced, how much, what was the end product, what was the end yield. So production data for some equipment is also there. And now what we have to do is ingest this data, okay, the IoT sensor data, ingest this from whichever current platform it is in, and then build data models and dashboards to analyze this energy consumption versus the production data and the equipment output. and then we have to come up with suggestions for which is the most optimum setting for a machine to operate for the most optimum production volume. And then if the machine operates at this volume, what could be the forecasted volume of product produced, and what are the optimum settings at which I should operate my machine for the least energy consumption. Then what are the targeted energy versus cost reduction. So these are some of the insights, and as you can see, right, just installing the sensors doesn't cut it, right? It doesn't work that way. So unless and until you are able to derive insights from the data, able to perform some sort of recommendations from the data, you need to unearth the story which the data is trying to tell you, right? Which is where the entire digital twin paradigm and analytics paradigm actually comes in. Okay, so the solution architecture which we proposed to them and which we implemented to them was actually getting these data into our Azure ecosystem, where we are going to model it. So the data will be pulled into a common data store using data factories, right? And then we'll have analytics. So the finally it will be housed into a Synapse warehouse, and then some out of the box reporting like cycle time and productivity and machine uptime and output and all will be your normal Power BI reports. And then your forecasting, your yield and certain suggestions about optimum operating times, and all of that will be done using Azure machine learning. And where again it will be sent to Power BI to give you intuitive insight into what the learnings or what are some of the insights which are derived out of your Azure machine learning models. So enough of theory, I will jump into some real how the digital twin looks like and works, right? So I have given you two links, YouTube links, okay, so which talk about digital twins. So please go through that. So this is creating the brewery of the future with the ABN Bev, right? And this is actually, as I was saying, one of the beverage manufacturers, and how digital twin is used there. So I would not walk through this. Definitely the other one, where we are creating replicas of real world environment. So not only the production lines, but right from the supply chain manufacturers, right? The supply chain, the manufacturing, the retail, the inventory, the warehouses, each part we are able to monitor in real time by the help of the digital twin which we create, right? So again, walk through this demo. I will show you some snippets of this demo. Okay, so for example, here as we are seeing manufacturing digital twin, so the digital twin is sorry, oh my god, did I lose that? Okay, so the digital twin is incumbent in the production design, engineering, factory operation, inventory management, and even distribution. So till that point, like from the source, the the source, the origination to the final, end user consumer, to that level of detail, we can actually do real time analytics with the help of a digital twin, right? So as you can see, for example, we are going to take an example of a t-shirt manufacturing. I can't really show you the digital twin solution for the the client, the fragrance manufacturing client, which we did for obvious reasons, right? Like it's already deployed in the client environment. So yeah, so we will actually see, like for example, for a t-shirt manufacturer, right from the various warehouses locations. So like for example, there are there are these warehouses from where the product is being shipped using probably for some routes it is a flight, for some routes it is a truck, for some route it is a ship. So we can track that, right? So this is like probably the supplier, okay, and then how he supplies to the factory. From the factory it is going to the various retailers and the various modes of transport, and we can actually look at that in real time. Okay, so we can actually mouse hover on let me play this. So we can actually mouse hover on each of these facilities here to see what is the the factory yield, the production. So for example, if I so if we want to look at one of the factories in Europe, then we can just click on that and efficiency of the factory so and so, the reliability of the factories XYZ. Let me reduce the volume. And yeah, so the key performance indicators are given. You can also see the info, the recent orders in that factory. So as you can see, the level of detail which is possible by the sensor installation and by the real-time tracking we get is phenomenal, right? The detailing which is possible with the help of digital twin. Okay. And then again, recent orders, you will see they will what is the factories working on currently, right? And then you can also monitor the modes of transport here. So if, for example, if I mouse hover on the mode of transport, then what is the type of shipment which is going, and then I can also monitor some of the other things like what is the ET, expected time, the status, it's on time or not, where it is right now, the latitude, longitude, and what are some of the weather parameters, right? Like probably for the raw material, there are certain preconditions in it should arrive. So you can also see that, okay, this is conducive. This is the humidity is actually okay for my raw material. And then so, I mean, it can be as detailed as we want to, right? And then now if you can also track problems. So now I have, you can see here, right, that I have certain alerts here on one of the outlets, okay, one of the supplier, one of the warehouses. So you can retailer. So then you can actually click on that and you can see that, so as you can see, right, so once you click on that, you will see that there is a problem here with one of the inventory for some factory in some of the location. Now you can click on that and and it will isolate that which is this factory in all of this ecosystem, right? So if you can see, if I click on that, I can see now isolate. So I'm isolating, like, this factory is supplying to which of the factories. Okay, so from this retailer is supplying to which of the factory, and then I can track that particular isolate that particular path and see which is the factory affected by the retailer. Okay. And then finally you can go here and then you can actually go to the factory, and inside the factory we can now zoom into the factory level. Okay, so here we will see, get some factory, for example, KPIs. So what was the efficiency, what is the reliability, and what are the recent orders? And I know that this is the factory which is affected by this faulty retailer, right? So then what I will do is I can actually click into view factory and then go into the very detail of this, right? So if I click on view factory, then I will zoom into this factory. Okay, so now, as I said, right, in a of the factory itself, the various production lines in the factory, the various equipments on those operating on those production lines. So each and every part can be modeled into a digital twin. So as you can see, right, these are the 3D models. So real-time 3D models of all the production lines we have in that factory, and we have reporting like at each part, right, at each point wherever the sensor data is installed and wherever we have modeled the sensor data, we will have reporting and insights. Okay, so as you can see, this is the overall factory related KPIs or reporting, and these are like the individual graphs which you see here are some of the reports on each of these constituent processes. So we can, yeah, so now, from the global digital twin of the supply chain, now we have zoomed into the factory digital twin. From the factory digital twin, we can zoom down into the individual production line digital twin. From the individual production line digital twin, I can zoom into the individual machine or part digital twin. Okay, so this is individual production lines we can actually see, and then you can see also, some of the metrics here, like the latest orders. Okay, so as you can see that So the production lines, as you can see, right, one of them is green and there are 3 alerts here. Okay, and then you can actually zoom into the ones which are having problematic things. So now when we have clicked into that, we can actually see that this is the time series insights into each of when the faulty t-shirts were being produced. Okay, so and then once we go into that, we can actually track the various parameters like humidity. Okay, so as you can see that line 1, line 2, line 3, line 4, and as we can see for the line 1, the humidity is very high, which could be like, one of the factors why the t-shirts were damaged, right? So yeah, so various, we can view the time series charts for that. And then you can see that, the humidity levels, you can infer that. So you can see that on the production line the humidity levels were very high. And then you can actually view the impact. So what is the impact if the humidity continues to be high, right? So you can actually view impact and then do a prediction. So if you click on predict, it will try to model, like, what will happen in the future if the humidity continues to be high, okay, for that particular production line, right? And then from the history, okay, from the history to this point of time, what was the humidity pattern and the production pattern, and if we predict it, then the quality prediction will tell you that what will happen if the humidity continues to be high. So we know that the performance will keep on declining, right? And there will be finally, end outlets, consumer outlets, which will be affected. So then once we view the impact, so tell me what are my end outlets affected. So as soon as I click on view impact, I will know that, this factory is supplying to which of the end users and what are the final, retailers affected, okay, or which are the following shop outlets which are affected, and how to stop those shipments. So I can order that the shipment be stopped or cancelled, or no more faulty t-shirts, so that no more faulty t-shirts are actually reaching the end users, right? And you can also see that, the factory, the end store in the retail store in Europe has having how many faulty orders, the retail store in some other provinces having how many faulty orders, and what is the estimated financial impact of all these faulty shirts or faulty faulty product. And then if I can cancel that, so I can actually see stop line, and once I stop line, then my shops cannot be affected, right? So if a shop in California is promised 1,000 t-shirts, then even if I stop the production of one of my factories, then I should be able to reroute the traffic from some other factories to my final shops, or to my shopkeepers or to my customers, right? So this is also done by our digital twin. So it can intelligently reroute, okay? So using optimization, once we stop the line, so it can reroute now. So for this particular retailer, end user, shop, consumer, which factory is now capable of supplying, so it is rerouted. So even if we stop the faulty line, what are some of the other outlets which have the extra capacity to live up to the promised product? So yeah, I mean, as you can see, wonderful stuff can be done with the digital twins, and the smart factory or the intelligent factory or the connected factory thing is no longer unknown secret, right? I mean, something which is unknown or which is just a wish list. It is actually turning into reality, and as has been demoed by Microsoft, I think, in their Ignite book, Build Event and Ignite Event. There are a lot of actual manufacturing companies, motor companies, who are actually moving on to this digital twin bandwagon and actually helping to save energy, helping to have real-time analytics, helping to have cost reductions, and working towards this future of real smart connected manufacturing. So with that, I am at the end of my session. So I'll be happy to take any questions, if any, or I hand it over to our organizers.
Yeah, thank you so much, Priyanka, for that amazing presentation here. So far we don't have any comments here in the chat, but I would still encourage everyone who listens or view this to keep posting questions in the chat, and then we can take them up here in our panel debate here. So I think we can just move over to our next step here, which is the panel debate. So we'll be bringing in all of the speakers, and we will have some open-ended questions that will hopefully bring you some more insight into how it is actually to work with machine learning and AI in the real world. Yes.
So, hi and welcome back, everyone. Thank you a lot for the nice sessions. All of them were really nice, and it was really, really insightful. And we actually got one comment from the viewers, at least, that we got really amazing and excellent explanations that we could listen to today. So thank you so much. And we do have some questions that are not necessarily only about this specific project that you were talking about, but in general in your real life project work, really. So can I go ahead with my first question? So the first question was, what is the biggest challenge for putting machine learning into production?
Dirty data. I'll just start. I often see, like, before you can even get into the data science, you have to know that the output is going to be clean, and you can't have clean output unless you know the input is clean. So data governance, data cleanliness efforts, all really, really key. And I see that on a large scale. So companies that I help, that's typically the biggest hurdle to getting something actually useful out of data science.
Yeah, true. So I have had instances where when I talked of data, right, like, okay, I'm fine. I mean, I built this digital twin, I built this analytics. Where is your data? So I have had instances where the client showed me screenshots on his mobile and said, yeah, this is my data. I was like, okay, fine. Yeah. So, and again, yeah, sorry, Madhumita. Another thing, for moving into production is, again, most of your models might work excellent in your MVP environment, your own dev environment, but productionalizing them, putting them into client environment is another challenge altogether. So you need all that ML ops and data drift and parameterized ML pipelines, which is a total, journey altogether, separate journey altogether.
Yeah, I completely echo that because I myself have experienced it, and I felt the pain so much that I wanted to solve that problem space. And I'm right now building products that could help like manage data quality or data observability. And I was sharing Third Eye earlier. Actually, a lot of our users of Third Eye, they are using right now Third Eye for catching data quality issues. Yeah, data quality, observability, governance are big part of this.
Yes, thank you a lot for the answers. And I think is it Håkan or Gosha who has the next
Yeah,
question
Gosha,
here?
you can go
Yeah,
ahead.
I can ask the next question. So, what do you spend most of your time on in a machine learning project? So, it's more analytics, machine learning turning, or maybe getting the API work?
Data annotation. Annotating data. So it's if it is a NLP project, yeah, getting the entire knowledge base ready. If it is a vision related project, then tagging images, annotating images. Yeah, so most of the time, again, so there's one saying, right, your model is only as good as your data. So unless you have real good data, there's no use of any AI ML whatsoever. So most of the time is spent in collecting, annotating, tagging data, images, audio files, video files, depending on the use case.
Yeah, similarly, I was going to say feature engineering and data engineering. So when we're trying to make sort of the results of the machine learning actionable, feature engineering on the front end. So that requires knowing the data. So in the world of consulting, I have to adapt to new data sets from totally different industries all the time. And to be able to know enough about it to engineer the features that don't exist and to do it in a clean way, in a way that makes sense and doesn't dirty the data or misinterpret the data, that takes time and thoughtfulness. And then data engineering sort of on the back end, linking up those pipelines where they need to go to be able to productionalize it, usually has a lot of unforeseen hurdles. And so people think you just build the model and it's great, and that in itself takes a lot of work, but hooking it up and making it live and productionalizing it takes a lot of time.
The two areas that I feel the pain right now and spend like takes a lot of time. One is data management overall, like start from end, like acquiring the data to make it data more readable format and then drawing it as a complete cycle. And the second one is the synthetic data, because you do want to do several tests and experiments and getting the synthetic data and making it work. And real world data would be more useful than cooked up data. We all can generate cooked up data, so that's another area. And if you're investing in research activities, it becomes all the more painful. And then another thing, big part is framing the problem. I think a lot of data science initiatives or products fail because we do not frame the problem correctly, and whom are we solving for and why we are solving for. And that's another big area I feel. I mean, I see the shift. People are now more focused on doing that, but it's not easy to also do that or validate your hypothesis.
Mhm. Yeah, we can take the next question is because we can see that many customers, they are maybe confused as to the value here of AI, and how did you convince your customers to actually use machine learning?
I'll go. I was going to say, for my example, it was a custom built thing based on a problem, right? And it wasn't really solvable any other way. It was also a little bit of a passion project from all of the people involved. So I don't think there was any convincing of clients in that case. In outside of my example, in my real work, a lot of the time the convincing of the investment has to have a use case to go along with it, and sometimes even sort of a proving out of that study. And so trying to do something small and manageable first and helping people see the value of it and then working them toward the solution. It's interesting because it's almost like this Venn diagram that doesn't overlap at all. Either clients don't want to use it, they're afraid of it, they don't think it's worth the investment, or it's a buzzword and they want to use it and they don't care if they have the necessary preparation or data or anything. And so having the right story to tell each type of audience and to say, you're not ready yet and here's what you need to do, versus you're ready and you could really benefit from this. I think it's important to know the differences between those customers and how to target what you're telling them based on the situation.
Yeah.
Priyanka, you
Madhumita, you want to go? No, yeah, go. Yeah, you can go first, Madhumita.
Sure. I completely echo with what Becky said. If I had to summarize the three things that I see is very, very valuable, it starts with, I mean, building the empathy with the user, and then kind of framing the problem in terms of pain and gain. I think that is one. And second, I totally agree that start small and then build on top of it. So really focus on one use case, go after that, and see if you can make your users successful in that, and they will see the value, and then they will go along with the journey. So it's very, very important, like what are the outcomes and the value to the user. Just focus on that, defining that very clearly. And the third thing is just be adaptive, and you learn over the course, and you need to be extremely adaptive and agile to user feedback. And then it's an iterative journey. There is no one solution that would work for all. So it depends on like context, but I think using this framework and understanding the user better, I think we could definitely make them successful and justify why ML is important versus not. But again, another important part also is not everything can be solved by ML. So it's very, very important, and that's where I would go back, like framing the problem and really think like if ML is the right solution for the user, and user will start building the trust with you.
Right. Yeah, for me, the challenge is not so much about ML as such, right? But then trying to define what AI ML actually entails to do for the client. So, in the terms of digital twin, as soon as we say digital twin, the client jumps onto 3D visualization. But 3D visualization is not AI, right? So it's having to ring fence the scope of AI ML or insights. So what sort of insights? Okay, just normal KPIs and measures are just reporting. That is not insights. So having to define and scope the ML. So something which is forecasted product or proactive maintenance, part maintenance, or increased uptime. These are some of the actionable AI insights which you're going to get, and that is AI. Having 3D visualizations is not AI. For me, the challenge, especially when it comes to complex things like IoT and machine learning at the edge, that is one problem. Second problem, which is again a very practical thing which I face, is customers have very ambitious insights, like computer real time computer vision streaming via vision cameras, and then the machine learning which has to be deployed at the edge. I don't have that much memory to do that much powerful analytics. So having the GPU based ecosystem, and then the platform costs which come with that. So if you want to go ambitious with GPU and machine learning at the edge and using tiny ML, you have to invest that much, right? But then you cannot have budget of peanuts and then expect me to build a Mercedes Benz engine. So I always need to play that balancing act, right? It is a tightrope walk for me to ring fence the scope, redefine ML, and also address their budget concerns. Yeah.
Thank you a lot, girls. And you talked about that the most of the time is spent with data preparation, data annotation, and so on and so on. And we got a question for that one, like which tools do you use for data annotation?
Okay, so so for data annotation, right, for an NLP related project, especially if you want to build ontologies, taxonomies, then you have a lot of OWL, which is web ontology language tools, or RDF tools like Protege, Pool Party, Fluent, which are open source. Some are paid. So we normally go with Protege, which is an OWL format. So this is one of the tools which we use for data annotation. For image labeling, there are other like CVAT and what is that, VOTT. These are some of the image annotation tools. NER tagging, you have Spacey, you have Spark NLP Labs. So some of these, these are some of my go-to tools for data annotation.
She stole mine, so I don't have more to say. I'll second it.
I just have to add one thing, like being AWS user extensively, I've used Ground Truth. And then there is another product I don't remember right now because they have changed the names couple of times. So that, and also we used to hire a lot of data annotators and then homegrown tools at LinkedIn, which was helping to do data annotation at scale.
Thank you. Do we have a next question? Håkan, Gosha?
Yes, so what kind of projects does the customer think about when they when they're using AI?
I think it depends on the consumer, right? I've got a lot of people here locally, sort of in the Midwest United States, that think AI is predictive analytics, and that's about as far as their brains take them. Then you have others on the far end of the spectrum that are AI replaces me and does my job and is everything a human is and more. I don't think there's a lot of good consumer facing education about what AI actually is and good examples. I think that's a real area of need, at least here locally.
Yeah, I totally echo with that. In fact, data literacy is one area that needs a lot of investment. A lot of people do not understand the value that data can provide, and like you rightly said, it's more of jobs. How my jobs will be taken away, but applied AI can do so much more than in users can just improve their lifestyle basically instead of doing like in manual task. It can be more automated, it could be more inclusive. You are just getting additional brain power that you can hook it up to yourself and keep going. There's a lot of interesting researches are happening right now in MIT, which is super cool, like where you can insert a chip and now the paralyzed people can talk. That is super interesting, like what AI can do the wonders. I guess what's needed is closing the data literacy gap, and in fact there's multiple efforts going on. In fact, I've been part of, like, I've co-founded AI for everyone.org, where we were trying to educate a lot of people even free of cost. But I guess there's a long way to go. I do not know why people are not as excited to participate, and they feel intimidated. I've spoken to a lot of people, like the moment they hear about AI, oh, I'm intimidated. I need to be like super technical. But I guess I found a path, like there are different things that you could do in the AI ecosystem, and people should like unblock themselves and explore more. You don't have to be technical if you're not interested in technical. You could be more business focused or doing several things in the AI space. But yeah, that's what I can say.
Yeah. So for me, the thing is, the customers typically, when we say AI, they think rocket science, right? So NASA level projects. So which sometimes, we fail to sort of appreciate that there is AI all around us, like our speech to text, text to speech, text translation, all your Alexa, Siri, Google, and the subtitles which are being generated on your YouTube videos. It's all AI, right? So AI need not be this complex rocket science engineering diagrams, right? I mean, it could be very simple, it could be very complex. So doing OCR out of a PDF document or form recognition is also AI. So typically, that is some of the expectations which we need to set, that some projects can be completed within a week, for example, if it is very simple AI, but very complex things might span an year also. So yeah, so educating them about their perception of AI is one of the major challenges.
Yeah, so then I think it's time here for the actual last question here for this evening. So that question has to do with how do you use versioning of your machine learning code, your data, and also your application code, so that all three of these are actually in sync.
So code management, I think GitHub is a very popular platform that everyone tries to use it. I see version control in many different ways. So one is like your core code that you need to do version control. One big picture we miss is data. You need to have also version control of your data or the features that we use for ML most likely, where a lot of business definition goes into building the features. And what if your business definition changes? And data consistency is another big factor, which is also needed a lot of versioning control governance into play in there. And besides, I think ultimately you're deploying a ML model into production. And once that is launched, like managing the version of your models and ensuring the health of the model is intact over a period when the data changes. And these are different areas, and the version control can happen like just not GitHub for your code, but several other products or platforms that enables that. And one of them I can think about data discovery platforms are in the rise, and compliance and data version control in the rise, data management in altogether. And there are several products. Like one of them I know very popular because I come from LinkedIn Data Hub. It's becoming very active in the community, and it does a lot of those version control and data management role.
Yeah, I was going to second GitHub and just persistence. I think the often overlooked part, which you said perfectly, is not just being in sync between your versions of code, but being in sync with the business, because those definitions tend to change, at least once you reach steady state of your code, change more often than your code will need to be updated. And so having processes in place and not just using all the same tool is huge.
Yeah. That sometimes it so happens, right, that not all of your code can be checked into GitHub for sensitivity and PDPA confidentiality purposes, right? So for which case we rely on Azure DevOps, wherein you will check it into your own Azure tenant subscription, and of course leverage on other libraries like MLflow, Azure ML experiments, various Azure ML experiments. Yeah, but apart from that, because largely we work on projects or engagements where we make the model ready and then hand it over to the client, and how they productionize it is their outlook or their headache, right? So yeah, not much familiar with other core tools like GitLab, for example, and ecosystem.
Thank you a lot for your answers, girls, and also for your participation. I really hope you enjoyed yourself today with us. And I say today because I almost said tonight first, but it's only tonight at my area, I think. Um, but yes, thank you again so much for your amazing presentations. It was very valuable from our point of view, at least. And I really hope that the audience would second that as well. And with that, I thank you so much for your participation. And remember to stay on the stream, please, because we would like to chat with you after. And to the audience, I want to say a big, big, big thank you for joining us today. And I can't wait to share with you what is coming next at AI42. We are already have ready with some new speakers for you. We have some new lectures ready for you. And I hope you'll enjoy the next half year with us again. And with that, I thank you everybody for the participation. Goshen Håkan for the amazing hosting again. And I hope to see you soon again.
Yeah, thank you.
Thank you
Bye.
all.
Bye.